Hi dear students, my name is Vikas and I am going to present the NSEP 2024 solutions here in this session. Let's begin. I am going to solve paper with code 63 and this is the first question that was there in the paper. So what does this question say? It says that OABC is a regular tetrahedron, each side of which is made of a uniform wire of resistance. So understand that the resistance that has been given to us, it's resistance per unit length, okay, and each side is of 2 meter length. So the resistance of one side would become 8 ohms. All right, this is the resistance of one side. And also keep in mind that a tetrahedron, it has six edges. All right, so it has six edges. Now the question says that we want to know the equivalent resistance between point O and M. So guys, if I connect this point to a battery and if I connect this point to a battery, all right, then pay attention to the fact that this line, okay, this line will become a symmetry line, and when the symmetry plane passes through the points where the battery is connected, then the points that are mirror images of each other in this plane, they have the same potential. So for example, if I now start distributing the potential, then the potential here, okay, the potential here would be this, let's say, if I'm assuming that I've connected a battery of, let's say, V volts, then the potential here would be V, here it would be 0, and then whatever potential we assume here, V1, the same potential will be here at V2. Okay, let me do it on the next page because my figure might be blocking the view of the diagram. So this was the tetrahedron given to us. Okay, this was the tetrahedron given to us, and this point was O, this point was M. So I was saying that if we connect wires from here and we connect to a battery of any EMF, let's say 100 volt, okay, then the potential here we can consider at 100, the potential here we can consider at 0, and these 2 points are going to be mirror images of each other in a plane that passes through OM. So therefore these 2 points must have the same potential, which basically means that the if the potential here is V1, if the potential here is V1, okay, then this branch, um, just a minute guys, yeah, so the potential here would be V2. Then we can actually fold the circuit. We can fold this circuit like this, like the right half of the circuit can be folded here, and when we do that, we will end up with a circuit which looks like this. This branch I have drawn, and along with this branch will get overlapped. Okay, so it had a resistance of 8 ohm, and parallel to it there would be another branch of 8 ohm. So this resistance will become 4 ohm now. All right, this edge was a single edge, this edge is a single edge, so it will remain to be 8 ohm. Okay, similarly this edge and this edge, they will overlap with each other, so the equivalent resistance here also becomes 4 ohm. All right, so we have taken care of like 1, 2, and then 3, and then 4, and then 5 branches. The sixth branch will get folded from from its midpoint. So 4 ohm resistance is here, 4 ohm resistance is here, and these two 4 ohm overlap, so that we get a resistance of 2 ohm here. All right, so we will get a resistance of 2 ohm here, and this point is connected to battery and this point is connected to battery. So this is the circuit we are going to get. Now as you can see, it is quite simple. This 8 and 4, they are connected in series, so this entire thing will become one branch of resistance 12 ohm. This 12 will be connected in parallel with the 4, so the value would be 12 into 4 divided by 16. That will give us 3 ohms. All right, and this 3 ohm, this 3 ohm and this 2 ohm, they are then connected in series, so the overall resistance is going to be 5 ohms. So let me see if 5 is there in one of the options. So option A would be the correct one to this one, and that is what we have provided in the key. So the correct answer to the question number 1 would be option A. All right, now we'll go to question number 2. Now guys, in this question it has been asked that what is the minimum force required to, so many of the students who had been preparing for JEE Advanced, they would be knowing this as a standard result. All right, this is a standard result to know that if there is a block on a surface, on a horizontal surface with friction coefficient mu, and you are given the liberty to apply force in any direction with the motive to shift the block. All right, the magnitude of the acceleration doesn't matter, we just want to shift the block, then applying the force at an angle of tan inverse mu results in the minimum effort. So in this case, the force that is needed is the minimum, Like if you apply force at any other angle and you try to move the block, then you will have to apply a force which is greater than this particular value. So that is one thing. So this is the angle, and this minimum value turns out to be, it turns out to be mu mg upon 1 plus mu square root of this. So if you know this result, then to this question you can straight away mark the answer as this option, option C. All right. If you don't know the result, then this question actually becomes a lengthy question. Like it is not a question to be solved in 2 minutes anymore. All right. So the paper of NSEP actually assumes that you should be aware of a lot of results that you need to be otherwise aware of as part of your preparation for JEE Advanced examination. All right. So we will see there are many other questions in which those results have been used, which are directly taught in Eklavya batches, in Eklavya Sankalp batches. All right, and or in generally in any other batch which are preparing for you for JEE Advanced examination. All right, so is this question a easy or difficult one? I would say that its question is easy for a JEE Advanced aspirant. All right, it is very easy. If you are only preparing for JEE Main, then it is a difficult question for you because it is unlikely that you would be aware of the result. So if you are preparing for JEE Main, then probably this question is difficult for you. All right, now what to do in case if you are not aware of the result, then what you are supposed to do in that case? What you will do, you will say that okay, let me apply force at any general angle, let's say theta, and then you will think about the other forces acting on the block, and that those forces would be the weight of the block, the normal reaction, and the friction force. Okay, then you notice that apart from this F, all the forces are vertical or horizontal. So you can break this force into a horizontal component, that will become F cos theta. You can break this force into a vertical component, that will become F sin theta. You can get rid of it because you have already broken it into two components, and then you will frame the equation. For example, N plus F sin theta will become equal to W. So from here you can get the value of N, that is W minus F sin theta. All right, so that is your first equation. Second equation, since we are just trying to move the block, even with a minimal or zero acceleration, we are fine. So we will say that F cos theta can be equal to the kinetic friction. All right, like not exactly equal, like a bit higher, but that bit is not definable. Like we cannot define it. It can be very, very small. So they are practically equal. So this would be written as mu n. Now here you have to be cautious, guys. Many of the students have this habit of writing mu mg instead of writing mu n. All right, so don't fall a prey to that habit. So you will write F cos theta is equals to mu times n, and n can be taken from the equation number 1, so that will become W minus F sin theta. So then you have to rearrange this, and then you will get F as cos theta plus mu sin theta into mu W. All right, and from here you get F as mu W upon cos theta plus mu sin theta. Now what we have to do here, what we understand here is that if we are applying a force at theta angle, then this is the force, this is the minimum force that we need to move the block. So if I choose a value of theta that maximizes the denominator, then my F would be minimized. All right, so if you know that trigonometric result, again this is something that you ought to be aware of. All right, if there is any expression of theta such as a cos theta plus b sin theta, all right, then the maximum value, this F theta, it is always less than equal to root of a square plus b square. So you can use this. All right, so the maximum value of this is root of a square plus b square. Therefore, if I go back to this, the maximum value that this denominator can have, it would be 1 plus root of 1 plus mu square. So therefore, let me write it here. The F minimum will be given as mu W upon cos theta plus mu sin theta, maximum value of this denominator. So the maximum value is how much? It would be root of 1 plus. So how I have written root of 1 plus mu square, that is because of this result that I have mentioned here. That's a mathematical result. Again, if you don't know this result, can we do anything? Yes, you can use derivatives to find out the maxima of this function. It's a function of theta, so you can find out the derivative. You can equate the derivative to 0. That will give you a certain value of theta. That will give you a certain relation between theta and a and b. In this particular example, it will give you a relation between theta and mu. Then you have to use that result to find out the minimum value of or maximum value of F. You have to put it here, and that gives you the answer. And therefore students, now you understand that why I said that this question is going to be a very difficult question for a student who has only prepared for JEE Main. When I say only prepared for JEE Main, I mean the student is not aware of these results. These results are something that you ought to be aware. All right, and generally the teachers cover these kind of result when there's good scope in the batch to teach stuff like this. Basically, in batches which are meant for JEE advanced preparation. All right, so on that note, I'll move to the next question. The correct answer to this question is option C. Again, this same has been provided in the Vedantu's answer key that we have shared. Okay, and a comment on this question. Yeah, this question easy for JEE advanced aspirant, difficult for JEE main aspirant. And can it be done under 2 minutes? So those who know the result, they'll probably do it in 10 seconds, 20 seconds. Those who don't know the result, they'll probably spend about 4 to 5 minutes if they get it right. If they don't get it right, they'll probably spend about more time. Now we'll go to the next question. Okay, so this question is based on heat conduction. Okay, and again, this doesn't look like a very difficult question. It says that the external wall of a room measuring 2 into 3 consists of a layer of pine thickness with the thickness of 2 centimeter, layer of rock wool in succession. The external temperature is 30 K below the indoor temperature given the thermal conductivity of efficient. Okay, so the values are mentioned here. The thickness of the layer of the rock that will allow a conduction rate of so guys, there is some misprint here. Okay, across the wall does not exceed 1. Okay, so what the question says, so let's say this is the wall of the room. If this is the wall of the room, then one layer is made of some material which is being called as pine, white pine, a layer of white pine. Okay, so this layer is made of a certain material and the detail is given. The thickness of this layer is 2 centimeter, that is given to us. Okay, and then there is another layer of rock wool. All right, so there is another layer. So this is a different layer, but we don't know the thickness of this. Let it be X. Okay, now the temperature difference across this layer is 36 Kelvin. So heat is flowing, let's say, from one side to the other. Okay, and the temperature difference is given to be 36 Kelvin. Let me just check whether I'm getting it right. Yeah, 36 Kelvin. And the question says that the thermal conduction rate does not exceed. So we don't have to exceed this. So if we don't want to exceed this, see, the temperature difference is fixed. If we don't want to exceed this, so basically 120 should be less, not 120, just a minute guys. So the heat conduction rate, that is delta T by resistance of the wall, this should be less than 120, which basically means that resistance should be greater than delta T by 120. All right, so the thermal resistance need to be greater than 36 by 120. So this will become 6 times 20 times. So it's actually 3 by 10 or 0.3 in SI units. Okay, so we have two layers of some thermal conductors and their equivalent resistance is 0.3. So what I'm going to do, I'm going to write 0.3 is equals to the first resistance plus the second resistance. The first resistance would be L. L is 2 centimeters. So 2 into 10 raised to power minus 2 divided by K. Now K of this pine, white pine is given to us, that is 0.10 in SI units. Okay, so I will write 0.1. Okay, 0.1. So L by K, A is area is 6. Okay, so 6. And similarly for the other layer, we don't know the value of thickness. That is what we are trying to find out. Okay, so this is L. Again, I'm assuming that L is in centimeters, so I'm converting it into meters. So X represents the value of thickness in centimeters. Here also it was given in centimeters. So yeah, so here also I'll assume in centimeters. And then the conductivity for this rock wool was 0.04. Let me just check, I'm not mistaken, it was. Okay, and the area is 6. So we need to solve this equation now. All right, calculators were allowed, so you can actually make use of the calculator to finish the calculation. Let me do it for you, or rather I'll just use the calculator guys. Now I'll use the calculator to quickly finish the calculation. So this number is 2 into 10 raised to power minus 2 is 0.02. I'll divide it with 0.6, so I get a number. Then I'll take it on the other side and I'll subtract it from 0.3. So that I'm doing. Okay, so that part is now done. I've got 0.266 is equals to X into 10 raised to power minus 2 upon 0.04 into 6. So the value of x will be, I'll just do it on the calculator now. So I'll multiply this 0.266 with uh, 0.24. That's the product of 0.04 and 6. I have multiplied that, and then I'm going to divide it with 10 raised to the minus 2. So dividing it with 0.01 gives me 6.4. So 6.4 centimeter is something that we should be seeing in the options, and yes, we do have that. So option B would be the correct answer to this question. All right, as we have seen here. So this is question number 3, I believe. Okay, let me write it here. This was question number 3. Okay, now we go to the next question. Okay, this question says a 240 kg block is suspended from a fixed point O at the end of a long L equal to 13 masters rope. A horizontal force F slowly pushes. Now guys, what you have to pay attention here is that F is not given to be a constant force. It says F is slowly pushes the block to move it to a horizontal distance that is 5 centimeter away to a position B where it remains stationary as shown in the figure. Statement 1, force F. Okay, so there are two statements given here. Statement 1 is that force F at the position B is this much, and statement 2 is that the work done by the force to bring box. Okay, so guys, let's see what is happening. So we have a thread which is 13-meter long, and from here a box was hanging. Then we started pushing it, and as a result this box came somewhere here. Okay, and this distance, okay, this distance is given to be 5 centimeter. Now let's understand that this horizontal distance is 5 centimeter. This is 13 meter. It is already given. So this length will be 12. Okay, so this length will be 12 meter. You can calculate it by using the Pythagoras theorem. Okay, now if this angle is theta, then what I'm saying is that we already know the value of tan theta. Tan theta would be 5 by 12. All right, it would be 5 by 12. Now force F is acting like this, tension would be acting like this, and mg would be acting like this. Okay, so this would be the situation. All right, or I can say that this angle would be theta. So t cos theta would be equal to mg, and t sine theta will balance out f. So tan theta will be equal to f by mg. All right, tan theta will be equal to f by mg, and tan theta is 5 by 12. So 5 by 12 into mg. Now mass is how much? Mass is given to be 240. So I'll multiply it with 240 into g. G is 9.8. So this will give me force. So this 12 gets cancelled. It is 20. I can cancel this 0 with this decimal place. 5 into 2 is 10. 10 into 98 is 980 Newton. So I can see that statement 1 is correct. All right. Statement 1, the force is, this is correct. Now work done by the force. So work done by this force can be said as the increase in gravitational energy of the block. All right, and this height is 1 meter. So I can say that work done by F is equals to m into g into change in height. That is 1 meter. Okay, so m is 240 into g is 9.8 into 1. So that should be the answer. And again, let me make use of the calculator. So this is 240 into 9.8. That gives us 2352 joules. Now let's go back and check the number here. It was indeed 2352 joules. So even this is correct. Okay. So both statements. So option D would be correct here, as both the statements are correct. Okay. So option D would be the right one here. And again, this was question number 4. Now commenting on this question, was this question easy? Was this question difficult? I leave it up to you guys. I think you would probably say that this question is indeed easy. I believe you say that because it is indeed easy. All right, so that was question number 4. Okay, now we'll go to question number 5. Let's see. This is question number 5. This is actually a very good question, guys. This is a very good question. I would certainly rate this question as one of the difficult question, even for students who are preparing for JEE Advanced, and it would be a nightmare for students who are only preparing for JEE Mains. All right, so it is going to be a very difficult question. It was a very good question, guys. It says that the number of radioactive nuclei of a radioactive sample experimentally measured as a function of time at t equal to 0, there were 50,000 nuclei. All right, and see, there is no ambiguity given here. At t equal to 0, these many nuclei are given. After 10 seconds, the nuclei count is a bit ambiguous. It can be anywhere between 600 to 400. So 500 plus minus 100, that means between 400 and 600. The half-life of the sample is estimated from this measurement. So we're using these measurements to find the half-life of the sample. The error in the estimation of the half-life. So guys, understand, the question is asking, it is not asking us the half-life, it is asking us the error in the estimation of the half-life. So let me first figure out how I'm going to make use of this data to find out the half-life, and then I will start worrying about the error in the measurement. Okay, so we know that n is related to the initial count as n naught 2 raised to power minus t by t half. So that's the relationship. So I can bring n naught to this side. So n by n naught becomes equals to 2 into t by, so this becomes, now I can take log, so ln n upon n naught is equals to minus t by t into ln 2. This is what we get. Again, I can take the minus on the other side and adjust here. So that will give us ln of l naught by n is equals to t by t into, now this t is the half-life, so t can be written as t ln 2 divided by ln into n naught by n. All right, so now understand this, we have framed the expression for finding out the half-life. Now we will talk about the error in half-life. So how do we do this? We differentiate this. We realize from here that the value of the half-life in this experiment is dependent on uh, uh, is dependent on the test time after which we are observing. So here ln2 is constant, n naught is constant, n is variable, n is changing. Okay, so I'll differentiate it with respect to n. So t will be treated as a constant, ln2 will be treated as a constant. So this is minus 1 upon ln n naught by n square of this, okay, into derivative of this. So again n naught will be treated as a constant, so minus 1 upon n square into dn. So this is the expression that we ultimately get. Minus minus will become plus, so t times of ln2 into n naught divided by n square ln n naught by n square into dn. Now we need to substitute the value here, guys. We need to find out the variation in the measurement. Okay, so how do we do this now? So let me just put the values. So this t was given to be 10 seconds. So 10 into ln2 is very close to, like, not like, ln2 is 0.7. Okay, so that is very close to 0.7. And then n naught was 50,000. Okay, and then dn is the uncertainty in the measurement of n, that is 100. Okay, divided by n square. So n was 500, so it would be 500 into 500. Okay, and then ln n naught by n. So n naught is 50,000, n is I think 500. So this is 50,000, this is 500. So what's the ratio? It's 100, right? It's 100. So it will be like ln 100 square. Okay, so and then yeah, I think you're taking care of everything. We just need to finish this calculation now. Okay, so this gets cancelled with this decimal point. So 35 into 10 raised to power 6, that's the numerator. In the denominator you will have 25 into 10 raised to power 4 into ln 100. Now ln 100 is 2 times of ln 10. So how much is that? Ln 10, 2.3, 2 times of that is 4.6. So 4.6 square. Okay, let me quickly finish this calculation. So this will become 35 divided by 25 into 100. Okay, so when I did this, I've taken care of this, I've taken care of this, I've taken care of this. Now I'll divide this number with 10 raised to power 4. Okay, I'll divide this number with 10 raised to power 4 and 4.6 square. So this becomes this is 6.6 into 10 raised to power minus 5 seconds. Okay, 6.6 into 10 raised to power minus 5. So let me go back and check whether we have an option like this or not. Okay, so it says here that we don't have an option like this. Okay, just a minute, guys. Oh, students, I just noticed that in the actual question paper, this number was 5,000, and therefore, instead of having a ln 100 here, we will simply have a ln 10, and we need to do the calculation accordingly. So it would be a square of ln 10. So this would not be 4.6, it would rather be 2.3 only. Okay, so the answer that I'm getting, it will not be this. It would rather be mm, okay, into, and similarly here also we will have two more zeros. So basically this will not be the answer after adjusting. So this will become actually 6. So after doing this and calculating, we get 0.026, all right, which is actually not present in any of the options. So yes, this question was actually marked as. So I guess there is a problem in the answer key that we have released. There also we have mentioned 0.026 as the answer. Most probably, um, they have actually either committed a printing mistake, or maybe the person who framed the question, uh, that person made an error of a factor of 10. So the answer, this question should be bonus or it should be dropped, I think. That is what going to happen in this question. So as far as the quality of the question is concerned, I think the question was uh, very difficult, I would say, and it's from nuclear physics. So yeah, it was from grade 12 syllabus. Definitely relevant for JEE Advanced. And this question isn't relevant for JEE Main because I don't think that questions of this caliber are going to be asked in JEE Main. All right. So that is it for this question. We'll now move over to the next question. We now begin solving of question number 6. So this question says an amount of heat equal to, I think this number may be misplaced. No, it's correct. 10.61 joule is given to an ideal gas at a constant pressure of 1 atmosphere. As a result, the volume of the gas increases. All right. So the heat given during an isobaric process can be written as NCP delta T. All right, and Cp can be written as N, like Cp is gamma R upon gamma minus 1. All right, and delta T and NR delta T. So let me separate gamma upon gamma minus 1. So NR delta T is same as P delta V. All right, so using this we can calculate gamma. For example, um, Q is given to us as amount of heat equal to, so 10.61 is equals to gamma upon gamma minus 1. All right, gamma upon into pressure. Pressure is 1.01 into 10 raised to power 5, and then delta V. Delta V is 30 centimeter cube. So 30 into 10 raised to power minus 6 meter cube. So when we finish this calculation, we will get the value of gamma. Now I'm skipping the calculation part, students, because I want to keep the solution short and sweet. So on solving this, you will end up getting a gamma of 7 by 5 or 1.4, indicating that we are dealing with a diatomic gas, and the correct answer would be option B. Alright, so this is how you will do this particular question. Simple question. I would say very simple question, straightforward question. Alright, so this is a very good question, guys. This is a very good question. It says a ball is projected from the point O with a speed u at an angle theta, and then after covering a horizontal distance L, the velocity vector was making an angle alpha below the horizontal. All right, and the height at that moment was h. The question is asking us to find the value of tan alpha. So let's see how we are going to do this question. So uh, the particle is projected with the speed u at an angle theta. It goes like this, and somewhere here it is moving at an angle alpha with the horizontal. So let's try to understand, guys. This is the initial velocity, this is the final velocity, considering this moment as the final moment. So this is the final velocity. All right, now understand this. In the initial velocity vector, all right, the delta v, the change in velocity vector would be g vector into the time taken. All right, and g is a vertical vector, it is a vertically downward vector. So this gt vector, okay, is a vertical vector, and this is what we get as the v vector. So this angle is alpha and this angle is theta. All right, understand this. Okay, so that is one thing. The other thing is that the time would be L upon u cos theta. I hope you get this. The horizontal component of the velocity is u cos theta. So the distance covered L divided by a u cos theta is time. So this actually is g into L by u cos theta. Okay, and this is u. Okay, now from here, notice that if I want to write tan theta, tan alpha, okay, so tan alpha would be written as this height. Let me change the color of the pen. So this height, okay, this height is this entire height minus mm, minus u sine alpha, because u sine theta, this height would be u sine theta. So this length is u sine theta. All right, so gt, that is gl by u cos theta. Okay, so this entire length minus u sine theta, okay, divided by this length would be u cos theta. Again, this is u, this is theta, so this becomes u cos theta. Okay, so divided by u cos theta. So this is this, like, this is our answer, but when we check the options are given in terms of h. Okay, so let me first write the value of h. Now h is the vertical displacement, which would be written as uy into t plus half ay into t square. So it would become u sine theta into t. T was L upon u cos theta. All right, plus half into minus g into t square, which is L square by u square cos square theta. So from here this becomes L tan theta minus gl square by 2u square cos square theta. Now watch this, guys. Like, this is what we are trying to find out. So this becomes what? This becomes gl by u square cos square theta, like gl by u cos theta divided by u cos theta, and minus this is what? Tan theta. All right, so I can see that this expression is very similar to this. So if I take out L as the common quantity, like, let me remove this L, let me remove one L, and let me write it as h by L. So this becomes tan theta minus GL by 2u. Okay, so um, let me do this thing. This entire thing can be written as what? This entire thing can be written as uh, tan theta minus h by L, and twice of this minus tan theta. So this becomes 2 tan theta. So this becomes ultimately what? Tan theta minus 2h by L. That is the value of tan alpha. So let me look for this option, tan theta minus 2h by L. Tan theta minus 2h by L. So option C. Option C looks to be the correct one, and this is indeed the answer that we gave in the answer key. So I hope you like this question, guys. This question was a good question. I would say that it is at par with the questions that you can expect in the JEE advanced examination. Certainly way above than as compared to what you would expect in a JEE main paper. All right, good question. Definitely good question. Okay, now that's a very standard question, guys. I think you must have done this question already. Like, so the question says that why not length? Why not length of the chain was hanging off the table? And what is the velocity when the chain completely becomes vertical? So this is actually a simple question. Like, let's say this is the table. Okay, this is the table, and let me draw another figure of the table. Okay, let's say it is here. So initially, y naught length was hanging. So this length is y naught, which is hanging, and the remaining length is here. So the remaining length would be, what is the total length? L. So this would be L minus y naught. And when this chain straightens, like it is completely off the table, then this L length is here. Okay. Now what I'm going to do, I'm going to write the energy equation. So I'm going to consider this as my zero height. This is my reference. Okay, and my process or my idea is to write u initial, and then to write u final, and then to write k initial, and then to write k final, and then I'm going to conserve the mechanical energy. Okay, so understand this, that for a object like chain, all right, it's a flexible object. So objects that can change their shape, the location of center of mass of those objects will also change. For example, in this figure we can assume the center of mass to be present at the midpoint. It is like a rod, it is like a straight rod, so center of mass would be at the midpoint. But here, assuming that it would still be at the same location of L by 2 from one end would be wrong. All right, and so instead what we will do, we will consider it as two objects, like one object kept here, the other object kept here. Okay, so let this has a mass of m1, let this has a mass of m2. All right, so while writing u initial, I will write m1 into g into 0. Notice that this entire object is present at 0 height. And for m2, I will write m2 into g into minus y naught by 2. Notice that the center of mass of this length is at the midpoint. So this height is y naught by 2. Now, how much is m2? So m2 can be written as mass per unit length into the length of the hanging part. So that is m2 into g into minus y naught by 2. So this becomes u initial. Okay. Now you can very well write u final by just replacing y naught by L, because you see that this y naught length has changed to L in the final. So figure, so uf would be minus y naught, no, not y naught, y naught needs to be changed to L. Okay, so it would be minus lambda g into L square by 2. This was minus lambda g into y naught square by 2. All right, so the kinetic energy was 0. Kinetic energy is half mv square. We will now conserve the energy. So we will write minus lambda g into y naught square by 2 plus 0 is equals to minus lambda g L square by 2 plus half mv square. And m is again, m can be written as lambda into capital L. So from here, what do we get? From here, this comes on this side. Lambda actually gets cancelled from all the terms, so lambda is gone. So we will get g multiplied by L square minus y naught square, and a 2 would be there. So we have taken care of this term, we have taken care of this term. This 2 will get cancelled because of this 2, and then we divide it with L, and then we take the root of this entire thing, and like this we get the speed. So the speed would be root of g and then L minus y naught square by L. So let's see the options. G into L minus, so A option looks to be the correct one. All right, so A option is indeed the correct one to this question. Again, regular question, I would say, a question that you can still find in JEE main exam. According to JEE advanced level, the level was a bit low. All right, although there was a trick involved, but yeah. Okay, now this next question, I think this question would have spooked many of the kids in the exam. It says that a Keplerian, okay, it says that a Keplerian telescope is adjusted in its normal setting. So normal setting means that we are talking about the situation when the eye is normal, which basically means that we are getting the image at infinity. All right, it is in its normal setting for parallels. Mounting on the objective has diameter d, and the diameter of the image of that mounting found by the eyepiece of the telescope is demagnifying. Now this is an interesting question, guys. Okay, so first of all, to solve this question, you should be thorough with the knowledge of telescope. So let's say the objective lens is this, and let's say the eyepiece lens is this. All right, somewhere here. So this is objective, and let's say, and this is eyepiece. Now this objective is mounted inside something, and that something has a diameter d. So basically this height is d by 2. All right, now let's consider this lens as the image, as the object. Like the question says that the image of the mount, okay, the diameter of the image of the mounting. Okay, so we are talking about the image of actually this entire arrow, you know, this mounting where it is mounted, that region that is producing an image in the eyepiece. Okay, and let's say L is the separation between these lenses. Okay, so let's see how it will function. So um, where will the image be formed? It says that okay, the diameter of the image is d. So the diameter of this red arrow, let's say the image of this red arrow is, let's say, somewhere here. It would be an inverted arrow somewhere here. So this is given as D. All right. Now we understand that this would be like a ray passing from this point to the optical center will go undeviated. Okay. So if this length is, let's say, L, and this length is, let's say, A, let me say, okay. So A by L would be same as small d by capital D. So first of all, you need to remember this. Okay, this magnification thing I've written. So A by L is equals to. Now next thing, when this telescope would be used, a ray coming from infinity, a parallel beam of light coming from infinity, that will create an image in the focal plane of the objective lens. All right, so it will create an image in the focal plane. Okay, and let's say if this angle is alpha, then this height, the height of the image that we will get would be alpha times the focal length of objective. Okay, let me write it again. It would be, alpha times the focal length of the objective. So this is the height. Okay, now if the lens is if we have prepared this setup in normal setting, then this image should be at the focus of the eyepiece. So this distance should be equal to Fe. All right, this distance should be equal to Fe. Okay, and this would be the angle. Okay, um, this is the angle that we are getting using this instrument, the angle that the image is subtending at the eyepiece. So let me call this angle as beta. So the magnification is defined as this beta angle divided by the default angle alpha that we would have got. So beta angle is how much? Beta angle is actually alpha into f naught, that is this height divided by this distance, which is actually Fe. Okay, so this is beta divided by alpha. So magnification is actually f naught by Fe. This is actually a standard result that we have just derived. Now we need to express this ratio in terms of this. So understand this, everyone. This length was f naught. So uh, a divided by f naught plus Fe. This L distance is actually sum of the focal lengths. All right. This is equals to d by capital D. Okay. So uh, we want to know f naught by Fe. Okay, um, we want to know f naught by Fe. And we want to know that in terms of the diameters. So A is what? A is um, so we will write a lens. Let's write lens formula using the mount as the object. So we will write 1 by V minus 1 by U equal to 1 by Fe. All right, because this lens is creating the image. So V will be plus A. So 1 upon plus A minus U would be minus L is equals to 1 upon Fe. So if I multiply this entire equation with F naught, so F naught by A plus F naught by L is equals to F naught by Fe. And notice that this is what we are looking for. So this becomes magnification. So F naught by A. Now instead of A, I can substitute this. I can substitute F naught plus Fe multiplied by D and capital D. Okay, yeah, plus F naught by L. So this is actually same as L. So we can take out F naught by L as the common quantity, and then this is D by D plus 1. Okay, so that becomes the magnification. And regarding F naught by L, so now we can write F naught by L is into D by D plus 1 is equals to M. I've rewritten this equation here. Now take this on the other side. So capital D by D plus 1 is equals to M into L by F naught, and L is F naught plus Fe upon F naught. Okay. So this becomes M multiplied by 1 plus, now Fe by F naught. Fe by F naught is actually 1 by M. Okay, this is 1 by M. so it becomes m plus 1. So this one and this one gets cancelled, so m is capital D by small d. So the correct answer would be option D. Alright, so the correct answer to this question would be option D. I hope you get this. So it was actually a good question, and to answer this question you should be aware of the theory of telescope, otherwise you can't do this question, guys. Alright, so let's move to the next question now. So this question says, in the circuit shown below, the resistance R is 3 into 10 raised to the power 3. Yeah, that value is correct. The inductance is 2 Henry and the capacitance is this much, have been connected to an AC supply of peak voltage 5 volt at the frequency omega. Okay. Either the switch S1 is closed or switch S2 is closed at one time. Maximum current is same, the frequency. So guys, see, when switch S1 is closed, current flows in this circuit, and this resistance and the capacitor, they form the impedance. Okay, when S1 is open and S2 is closed, current flows in this circuit, so now the resistance of the circuit is actually 2R. Alright, and because we are getting the same value of maximum current in both the cases, that means the impedance should be same in both. So we should be able to write root of R square plus 1 upon omega C square is same as root of 2R square plus omega L square. Alright, so this would mean that R square plus 1 upon omega C square is equals to 4R square plus omega square L square. Now, we've been given the value of R, we've been given the value of C, we've been given the value of L, and this Vmax value will not be needed in the question. And we want to calculate the frequency. Alright, we want to calculate the frequency. Now understand this, guys, they have asked the frequency and not the angular frequency, and here is the catch in this question. Okay, when we solve this, okay, like if I put the value of R as root 3 to 10 raised to power 3, it becomes 3 into 10 raised to power 6 plus 1 upon omega. Omega is something that we are trying to find out. Omega square into C square. C is 1 micro. Alright, so 1 upon C square actually becomes 10 raised to power 12 here. So let me write that is equals to 4 into R square. Actually we can have like we can cancel this and we can make it 3, so 3R square. So instead of writing it here, or maybe I can write it as minus 3 times. So now this becomes minus 3R square here. So we have taken care of this. So this term is not needed. Omega square into L square. L square is 4. So we can rearrange this term to make an equation like 4 omega raised to power 4. 4 omega raised to power 4. And then plus 9 omega square, 9 omega square into 10 raised to power 6. Okay, minus 10 raised to power 12 is equals to 0. So this would be our equation. Okay, this would be our equation, solving which we can get the value of omega. Again, this is an equation, this is a quadratic equation in omega square, and I don't think it's very difficult to solve this quadratic equation. So once you solve this quadratic equation, okay, what you will get for omega square, or should we solve it? The value of omega square that you will get, okay, let me solve it only. So that would be minus b, okay, plus minus root of b square, so that is 81. I'm keeping this away for now. Plus 4ac, so 16, and this entire thing will have a power like into this. All right, so this divided by 8. Okay, so this becomes how much? This becomes like 10 raised to power 6 can be taken out as a common quantity. Root of 80, root of 81 plus 16, that's 97. Okay, so root 97 is 9.848. Let me write it here. So 9.848, 84, rather I can make it as 9 only. Okay, minus 9. All right. All right, this divided by 8. So how much does that become? So that becomes just a minute. That becomes 0.1061 into 10 raised to power 6, and that's the value of omega square. So from here omega can be obtained as, omega will be obtained as 325.74 radian per second. Now understand that frequency would be omega by 2 pi, so this needs to be further divided by, okay, this needs to be divided by 2 pi, and when you do that you get the value of 51.84 hertz, okay, which is not there in the options. All right, but we do see an option, uh, like we do see an option of 325 similar to this, so I guess that is incorrect. 51 point, this should be the answer, so this should be a bonus question, I would say. All right, standard question from alternating current series RLC circuit. This is not a series circuit, but because we are closing only one switch at a time, so effectively the circuit that we are solving is a series circuit. Okay, so for this question I think bonus needs to be awarded. The correct answer would be 51.84. All right, now I'll go to the next question. Okay, so this says there are two given physical quantities A and B. Uh, which of the is dimensionless? Okay, guys. So here, let's not try to calculate the dimension. Let's try to use something else. So I hope you will recognize that in Bernoulli theorem we get a term called rho v square, and in Bernoulli theorem this rho v square get added to pressure, like P plus half rho v square plus m rho g h. So this rho v square needs to have a dimension of pressure. Pressure can be written as force upon area. All right, so force upon area into d. D is the diameter. So what we get are the dimension of area by diameter. So we get the dimensions of length. So A is definitely not dimensionless. Now let's talk about B. So in B it is rho v d by eta. Now again, don't need to substitute the dimension because you probably don't remember it. But what I can do, I can write rho v d by eta as what can we say, like force is written as eta a dv by dx. All right, now understand this, that dv will have the same dimension as velocity and dx will have the same dimension as length or diameter. Okay, so um, uh, a upon d will have dimensions of length into velocity. Okay, so rho v d by eta. Eta is force divided by length into velocity. Okay, now notice this d into L is area, and then again rho v square. Rho v square is pressure. Pressure into area is force. So they get cancelled. So yeah, B is dimensionless, but A is not. So B option would be the correct to this. All right, getting this? So this question can become very difficult depending upon the formula that you're trying to use. If you don't use the right formula, then of course it can become difficult. Yeah. Right now, I think it was pretty simple. Okay, like, okay. Now the next question. A uniform inextensible string of length L mass M suspended vertically from a rigid support transverse process. Okay, guys, again, this question is a fabulous question. It's a very good question, guys. And again, the students who have been preparing for JEE advanced examination, they will probably find this question easy. All right, because there is a result that we are going to use this. That if there is a string, and we are considering the mass in the string, in this string, if a pulse is generated and the pulse starts traveling along the string, then the acceleration of the pulse, like the speed would be higher as the pulse go higher, and the acceleration would be g by 2. So if the pulse is accelerating from below to upward, then the acceleration would be g by 2. If it is coming from top to bottom, all right, then the acceleration would be minus g by 2, because the speed will decrease as it is coming down. Okay, so that is one of the key ideas here. So the question says that we generated a pulse at the top of the string. So we have generated it here. So keep it in mind that at this point, what would be the velocity of the pulse? Okay, so that velocity will be given by root of tension. Tension will be same as the weight of the entire string. So root of tension divided by mass per unit length. So m divided by L. Okay, so it would be root of GL. So the starting velocity would be root of GL, and then the acceleration is negative, like the speed is continuously decreasing. Okay, and at the same time we have dropped a ball here. So after t time, if the pulse is here, the ball is here. So let's equate the displacement. So for the pulse, we will write initial velocity to root GL. Okay, initial velocity into time. Okay, minus half okay, g by 2 t square is equals to, for the ball the acceleration is downward. Okay, it is falling freely, so I've written half gt square. Now if we solve this, we get root gl into t is equals to um, half, like 1 plus half is 3 by 2, so it becomes 3 by 4, I believe. So 3 by 4 gt square, 1 t gets cancelled. So the time is actually 4 by 3 root of L by G. Okay. So this is the time. The question asks us that ball will pass the pulse at a distance of from the top of the string. So we want to calculate this displacement. So this displacement is very simple. It is half into g into t square, so that is 16 by 9 into 2 by g. So g gets cancelled, this 2 gets cancelled. Okay, did I commit some mistake? Oh, my bad, this was 2, this was not L. This was L, this was not 2. So this 2 is here. Okay, so this gets cancelled, so it becomes 8L by 9, which is the right answer here. Alright, so this would be the case. Now we go to the next question. Okay, here we've checked the answer. We go to the next question. Okay, what does this question says? In a positron decay radionuclide, again guys, again, if you're preparing for JEE advanced examination, you probably have done a be a positron decay. We also call it as a beta positive decay. So in this, how is the Q value written? The Q value is written as the mass of the reactant, which would be C here. Okay, so mass of C minus mass of B. Now, what is the mistake? What is the most common mistake that many of you make or you forget? That it would be minus 2 ME also. All right, that would be how this came. Okay, into C square will be the answer, but let me tell you how this came. So the Q value will be given as a mass defect into C square, and mass defect would be the initial mass minus the final mass into C square. Okay, so the initial mass, okay, the initial mass would be mass of C11 atom. Okay, mass of C11 atom minus 11 times the mass of electron. So that is the mass of C11 nucleus. Okay, and in a similar manner, mass of this boron, mass of the boron would be again mass of boron, which is again 11, but minus 5 Me. Guys, here I did wrong. It would be 6 Me. Carbon's atomic number is 6. Okay, and then one of the product is a positron, so this is your net product multiplied by C square. So this becomes equals to what? Notice it becomes Mc, mass of Mc atom, okay, minus mass of B atom, and then minus 2 MEC square. So you got this. Now you have to substitute these values that are given here in a calculator, and you need to finish this. Instead of multiplying with C square, you can actually multiply it with 931.4, and you can see what number you are getting, and that number would be the answer. I'll tell you that when I did this question by putting the values, I got 0.94 MeV and I got it properly, so that should be the correct answer. Alright, so that was question number 13. Okay. So next question says, in a Young's double slit experiment, a bright fringe is observed at y equals to 1.5. Okay, so in a Young's double slit experiment, okay, at a certain location, this height y is given to us as 1.5 centimeter, and here a bright fringe is observed. Okay, the question is asking how many dark fringes would be there between the center and the said bright fringe. So let me first figure out that this distance is what multiple of the fringe width. So for that, I will first figure out the value of fringe width, which is given by d lambda by small d. So the value of d is 1.4. Okay, so 1.4 into lambda is 612 nanometers. So 612 into 10 raised to power minus 9 meter, and divided by small d, which is 0.4 millimeter. So 0.4 into 10 raised to power minus 3. So we will calculate the fringe width from here. Let me do the calculation. So it would be 1.4 multiplied by 612 divided by zero point 0.4. Alright, so this comes out to be 2142 into 10 raised to power minus 6 meter. So this is 2.142 millimeter. Alright, now y is given to us as 1.5 centimeter, that is 15 millimeter. So I want to know that y is what multiple of beta. So y by beta is okay. I'm doing it. This number comes out to be 7.002. So what we have understood here is that this is the central fringe, then the first bright fringe, then the second bright fringe, and like this. So let's say the third, and so on. So this one is the seventh one. This one is the seventh one. So between two bright fringes, there would be a dark fringe. All right. So here would be the first, then the second. So notice that below the first bright fringe is the first dark fringe. Below the second bright fringe is the second dark fringe. So below the seventh bright fringe, there would be seventh dark fringe. So total of 7 dark fringes are there. So option C would be the right one. All right. That note, we'll go to the next question. Illuminated point object is placed in front of an equiconvex lens of refractive index. Okay. And distance. Okay. So we'll first make we'll draw the situation. It says that there is an equiconvex lens of refractive. So an equiconvex lens is there, and here let's say the refractive index is given to us as 1.5. Okay, the focal length is given to us as 40 centimeter, and then a distance. So this distance is 120 centimeter where an object is placed, and then there is water up to 40 centimeter distance. So behind lens up to a distance of 40 centimeter somewhere. Okay, this is water. How we have managed this, that's a different issue, but somehow you manage this, and this distance is 40 centimeter. Okay. The final image on the principal axis beyond the lens. Okay, so this is what you are supposed to find out. So first of all, I would like to know the radius of curvature of the surface. For with that, we are going to use the lens maker's formula. All right, so we are going to write 1 upon 40 is equals to 3 by 2, that is 1.5 minus 1, and then 1 upon r minus 1 upon minus r. All right, so the radius of curvature of this surface would be r, and for this surface it would be minus r. So yeah, solving this, we get the value of r as 40 centimeter. Okay, now I'm going to use the lens formula, assuming that this length is surrounded by air. Here I'm going to use a key concept, that we can introduce a thin layer. A thin layer of any medium can be introduced anywhere, and it doesn't affect the location of the image. All right, so I'm assuming that a thin layer of air is present here. All right, because this thin layer of air will act as a lens of 0 power. See, for this thin layer, this radius and this radius, they are identical, so the focal length will be infinite, so the power would be 0. Okay, so I'm going to use the length formula. So V is equals to UF upon U plus F. For U, it would be minus 120. Focal length is plus 40. So U plus F will become minus 80. So this becomes plus 60. All right. So what we understand from here is that the rays coming from this side, after passing through the lens, they are headed towards a point which is 20 centimeter, like which is 60 centimeter from the lens. So when the rays strike this boundary, which boundary? The boundary that is between air and water. All right. So I'm talking about this boundary. This is a curved boundary. Okay, between air. Remember that the thin layer of air was assumed here. So air and water interface. Okay. So now we are going to write the refraction at a curved surface equation. So mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. So mu2 is the refractive index of water, which is given to be 4 by 3. V is we are trying to find out. Mu1 is air because the ray is coming from air. Remember that a layer of air has been introduced here, and therefore we were able to apply the length formula. All right. U would be plus 60 is equals to mu2 minus mu1 is 1 by 3, and the radius of curvature of the surface would be minus 40. All right, so this is the equation we are getting. So on solving this, we will get 4 by 3v minus 1 upon 60 is equals to minus 1 upon 120. So 4 by 3v is equals to, this will go on the other side, it will become 1 by 60. So 1 upon 120 is what it will become. So the value of V would be 160 centimeters. So after the rays, they refract at this curved boundary, the rays are then headed towards a point which is at a distance of 160 centimeter. Okay, so these rays are headed for a point which is at a distance of 160 centimeter. Okay, but then again, refraction here will take place. Okay, refraction will take place here, and now the rays will bend away from the normal because the ray is going from denser to rarer medium. So by bending away from the normal, they will probably convert somewhere closer here. All right, and the distance always changes by a factor of mu. We are seeing that the distance will reduce. So this distance, okay, this distance was 120. So ultimately the distance will become 120 by mu. So it would be 120 divided by 4 by 3. So it becomes 90 centimeter. See this, it becomes 90, yeah, 90 centimeter. So 90 centimeter from this edge means from the lens the distance would be 50 centimeter. No, 130 centimeter, I'm sorry. The distance would be 130 centimeter from the lens, and the image would be real. The image, the value of V and the nature of image would be it would be real. In the question I'm checking whether it is given real or virtual. Here all the options say is virtual, but I have, so guys, there is a typing error in this question. In the options given, this option was given to be real, and even this option was given to be real, because we are getting the answer as real, and D option would be the right one here. So there's typing error in that, and therefore I'm keeping this PDF of the paper with me so that such mistakes can be, the typing mistakes can be identified. So the correct answer is option D here. Okay, the correct answer would be option D. Okay, now we'll go to the next question. Okay, now this question says a paramagnetic gas at room temperature is in an external uniform magnetic field of this much. The atoms of the gas have a magnetic dipole. So guys, the question is explaining a lot of things, but ultimately what is happening is that first the magnetic moment was aligned parallel to the magnetic field, and then it was anti-parallel. So we have to find the value of the change in energy. So we know that when it is aligned, okay, um, like if I calculate the mod, it would be P initial minus P final. On one side it is aligned, and then it is not aligned. So 2 times of mu into B, that should be the answer, because on one In one scenario, when it is aligned, the energy would be minus mu b. When it is not aligned, the energy would be plus mu b. So when you take the difference, it becomes 2 mu b. So that is going to be the answer. Okay, so let's just do the calculation directly. So 2 times of mu. Mu is given to be how much? The gas, the atoms of the gas of magnetic dipole moment of 1 Bohr magneton. So it would become E H by 4 pi m, okay, into magnetic field. Magnetic field is given as 1.5 Tesla. All right, so this will become, let me again check the values. There everything is okay. Yeah, 1.5 Tesla is correct. Yeah, everything is correct. So this would become 3 by 4 into EH by pi m. Okay, yeah, okay, and the options given to us are in electron volt. Okay, so what I'm going to do, this E, I'm not going to substitute for E. I'm just going to, write it separately. So all this uh, should be in the SI unit, which will turn out to be volt. So that should give us the answer. Okay, now I'm using the calculator, okay, to calculate these values. So 3 by 4 is 0.75 multiplied by H, okay, multiplied by H, okay. Mm, I have to do it again. Okay. Divided by pi m. Okay, divided by pi. And this m represents the mass of electron. Okay, this represents mass of electron. Okay, so this comes out to be 0.00017365. This is the number I'm getting on the calculator, and because everything is in SI unit, so we'll get the SI unit of volt. So this turns out to be 1.7 into 10 raised to power minus 4 electron volt. And if we compare it with the given expression, we discover that x will be equal to 1.7, which is actually one of the given options as well. So B option would be the right one to this. All right. So question, I would say definitely good question for JEE main level also and JEE advanced level also. So you can find such question in the JEE main paper also and JEE advanced paper also. Okay, now the next question talks about glass capillary with inner diameter is vertically submerged in water. So inner diameter is 0.4 millimeter. That information is correct. Height is 0.25, 25 millimeters. So this is also correct. Surface tension is 0.0. So that is also correct. Okay, so first of all, let us. So what does this mean? It wets the water completely. It basically means that the angle of contact is to be considered as zero. Now, guys, the formula that is going to be used here is that the height that the liquid rises in the capillary tube, it's given by 2t cos theta by rho rg. And then there's another thing, the radius of curvature of the meniscus. Okay, this radius of curvature is r by cos theta. All right, so this can also be written as 2t by rho capital RG, and then it becomes h into r equal to 2t by rho g, which is a constant. So when the tube is of insufficient height, okay, then this is the equation that we are supposed to use. So first let us calculate this number. So this number is 2 into 0.073 divided by density, that is 1000 into r, into cos theta would be 1 here. Cos theta would be 1. So because it is wetting the surface completely, because theta is 0. So the tube radius, this meniscus will take the shape of a hemisphere, and in this case the small r and capital R becomes equal. All right, but otherwise we have to use this. Okay, so R, it was given to be how much? The question says that the internal diameter was zero point 0.4. So here it is 0.2 into 10 raised to power minus 3 radius. Okay, into G. So let's take G as 10. Okay, the question doesn't say anything. Okay, so how much is this value? So this and this gets cancelled. This 0.2 and 10 becomes 2. 2 gets cancelled. Okay, so it is 0.073 meter, which is like 73 millimeter. So the liquid can rise to a height of 73 millimeter. All right. Now the height, the part protruding is less. It is only 25. So let's read the options now. The length of the capillary above water surface is insufficient water to flow out. So that is correct. The length of the capillary is insufficient. So the water will flow out as a fountain. That is not correct. When the height is insufficient, it doesn't flow out. It then follows this law. All right, like it reaches the top and then the shape of the meniscus changes until this equation is satisfied. So, like if it is insufficient, like this is the tube and the liquid has already reached the mouth here, so then the shape changes. So the value of R increases to accommodate this equation. So this H indicates the tube length. So this is not correct. Water will rise to the brim and meniscus and form a meniscus of radius. So we'll calculate the radius using this formula. So capital R would be equal to 2t by rho g, 2t by rho g into 1 upon h. So this will become 2 into 0.073. Then rho is 1000, g is 10, and h was 25 millimeter. Okay, so this gets cancelled. So this becomes how much? This becomes 2 into 0.073 divided by 250. Okay, divided by 250, and in millimeter it becomes 0.58 mm. Okay, let me just check. I have substituted all the values correctly. Yeah, 2t. Yeah, so radius is, so this is not correct. Okay, it says water will rise to the brim forming a meniscus of radius. So yeah, this can be approximated as 0.6 mm. That is a good approximation. So this option is correct, and this is incorrect. So C option would be the right one for this. All right, so C option is the right one to this. All right, students. Now we go to the next question. It says a container A in the figure holds an ideal gas at a pressure of this much. So the pressure is right, that is given, okay, at 27 degrees Celsius. It is connected to the container by a thin tube fitted with a closed valve. Container B has, so if this has a volume V, this has a volume of 4V. Okay, again, guys, the figure might be hidden behind my figure. So I'll draw it here. So we have one chamber of volume V. We have another chamber of volume 4V, let's say. And initially the gas here had a pressure P1, the gas here had a pressure P2. The temperature here was T1, the temperature here was T2, and there was a valve in between. Okay, then what we did, we removed the valve. So once we remove the valve, the pressure in both chambers is going to become equal, and we have maintained the temperature as T1 and T2. So now the pressure is P, the pressure is P. So what do we do? I'm going to write N1 plus N2 is equals to N1 plus N2. So the number of moles present here was N1. Let's say it was N2 here. Eventually this entire, um, again, some different amount of moles would be present here, but it would be like the total number of moles is going to remain same. So how are we going to write N1? We are going to write N1 as P1 into V, all right, divided by R into T1. Okay, and then N2 would be P2 into V divided by R into T2, and finally the pressure is same in both the chambers. So P into V divided by R into T1 plus P into, this V is actually 4V, into 4V divided by R into T2. So from here, the R gets cancelled. Okay, the V gets cancelled. So the pressure is P1 by T1 plus P2, 4P2 by T2, okay, divided by 1 upon T1 plus 4 upon T2. Now we have to just substitute the values. So mm, P1 was this much, 5 times of 10 raised to power 5, Okay, so I'll substitute it here. So 5 divided by, I am keep 10 raised to power 5 will get cancelled, or it will not get cancelled, but it will come out as the common quantity. So T1 was 300. Okay, 300 plus P2 was 1. Okay, let me just check. Yeah, and temperature was 400. Okay, divided by 1 upon 300 plus 4 upon 400. Okay, and then into 10 raised to power 5. So when we finish this calculation, you can see that these double zeros can also be taken out as the common quantity, and in fact they are going to get cancelled. Okay, so we are left with this is 5 by 3 plus 1. Okay, so 5 by 3 plus 1 divided by 1 by 3 plus 1 into 10 raised to power 5. So this is the final pressure. So it will be 5 plus 3, 8 by 4 into 10 raised to power 5. So 2 into 10 raised to power 5 would be the final pressure. Um, so in kilopascal, it can be written as 200. So option A would be the right one to this question. All right. So that was question number 22. Okay. We next go to question. Okay. Now this question says that a thin plast is this, which is a quarter of a circle. So guys, again, if you are aware of the result of potential at an axial point of a uniformly charged disk of radius r, all right, then you can do this question very easily. The formula is sigma by 2 epsilon naught and then root of r square plus x square minus x. So that is the formula. Now this is the formula for the complete disk. Okay, this is the formula for the complete disk. Here we have only quarter of a disk. So first of all, understand this, that every quarter contributes equally. So if we have only one quarter, then the formula will become by 4 of this. So sigma by 8 epsilon naught, and then this root of x square plus r square is actually this distance, and this distance would be, see, the radius is 0.6, this is 0.8, this distance is 0.8, so it's going to be 1 meter. So I can write 1 here minus x, x is this which is 0.8. Okay, so 1 minus 0.8. Okay, so this will become sigma by 8 epsilon naught into 0.2. Okay, so this will become sigma, this is 2 by 10, so 40 epsilon naught. Sigma by 40 epsilon naught is what we are looking at. So this option D would be the right answer. Okay, again guys, standard result, if you are aware of the result, question is doable. If not, then the question is going to take a lot of time, because then you'll have to derive the result, which is actually going to consume a lot of time. So okay, now this is again a controversial question. We mark this question as one of those questions which has controversy in it. So what is the controversy here? The controversy here is that the question doesn't say that the spring is massless. So we are not sure whether we have to consider mass in the spring or not. Generally, we take the strings to be massless. If it is massless, then what happens is that massless entities can have large accelerations in them. So let's say if this was the surface, this is one end of the spring which is fixed, this is a massless spring. So the moment you exert a force F on this, it will immediately compress and come to a value of, like the question says that compression is, let's say, E. All right, so this E compression will correspond to this equation. Note that it will not go beyond this equilibrium position because there is no mass, there is no inertia. So it will not overshoot this position. Normally, if there would be a mass attached at this end, and then you push the block, you push the mass with a fixed, with a constant force, then it accelerates up to the equilibrium point, and then it overshoots the equilibrium point because of the inertia. There is no inertia here. So the moment we reach the equilibrium point, and the moment you try to cross the equilibrium point, all right, since there is no mass, even a slightest imbalance of force will create infinite acceleration, which basically means that it will bring that end of the spring to an abrupt halt. Okay, so this is the situation right now. Okay, Now the question says that you have changed the direction of the force and you have made the force double. Okay, so that's okay. So if first you are exerting a force, let's say F like this, now you are exerting a force 2F like this. And if it is a massless spring, then what will happen? This is the natural length of the spring. So from this position, it will go to a new position, which is like, which has an elongation of 2 epsilon, because now 2F needs to balance by K into elongation. Um, so that's it. Again, it will come to an abrupt halt here. It will again come to a. So if the spring is massless, then the maximum extension beyond the natural length would be this one. So this is what we have given you as the answer. But what we suspect could be the other possibility, but that would be like that possibility is based upon imagining that there is a mass attached to the other end. All right. If we consider the spring to be massless and then solve, then this is if we imagine from our side that okay, let's say suppose there is a mass attached at this end, then what is the scenario? So earlier, if uh, the compression constant, the spring is compressed under the action of a constant force, the compression of the spring is this much. So we have compressed it. So this epsilon or this E, whatever the symbol is, okay, this is F by K. All right. Next, when you reverse it, what will happen is that the equilibrium position will be at 2F by K, but the block will overshoot the equilibrium position, and this position, because the block started from here, this will become one of the extreme position. This is the equilibrium position. So the amplitude is 3F by K. So it will go to a distance of 3F by K on the other side. So the maximum elongation from the equilibrium position is 5F by K or 5E. So this is the possible, this is the other possible answer that may be given. Now we are not sure whether this question will be given as bonus or whether A or give will be given as correct or whether D will be given as correct. We have marked A because what we are assuming, or like what my thought is, that if this question comes in JEE advanced exam, then they would surely go with option A. That is again my opinion. That is that other people may differ with me. Even the examiner can have a different view than me, and the answer given could be very well D also. So, but I have told you the situations, like if the spring is massless, then option A is correct. If we are imagining some mass attached to the spring or there is mass in the spring itself, then the option would be option D. All right, and that's it. That's it for this question. We'll now go to the next question, which is again a good question. Okay, this one would be question number 25 now. All right, so what does this question say? This question say that there is a point A and there is a charge, let's say Q naught here, and at some point, this point is P. All right, let the distance be D naught. Okay, so it is producing a potential of 3 volt. Okay, so we can say that K Q naught by D naught is 3 volt. Okay, so that is one thing. Now the charge starts leaking and it is traveling. All right, so what is happening is that the charge has charge has come here and the value has become Q. How is Q written? Q can be written as Q naught minus RT, where R is the rate, the constant rate at which the charge is leaking. All right, and let's say this distance is X. Okay, so the new potential would be written as K Q naught minus RT divided by D naught minus X. Okay, this would be same as the previous value, which is K Q naught. Like the particle is moving in such a manner that the potential at P remains constant. So from here, this K gets cancelled, and what we get is that Q naught minus RT by Q naught is equals to D naught minus X by D naught. In other words, 1 minus RT by Q naught is equals to 1 minus X by D naught. 1 gets cancelled, so the value of X is given as RT naught by Q naught. RT naught by Q naught into D naught. Okay, so this is what we get for. So if I differentiate this, so dx by dt will be the velocity. So it turns out to be r into d naught, divided by q naught. So it's a constant velocity. Now this q naught by d naught can be picked from here, we are looking for D naught by Q naught ratio. So D naught by Q naught ratio is K by 3. So R into K by 3. R is how much? R is given to be 3 microcoulomb per second. So this is 3 into 10 raised to power minus 6. K is 9 into 10 raised to power 9 and 3. Okay, 3 SI unit volt. So this 3 gets cancelled. So this is 9,000 meter per second. So this is the speed. Now the question is asking for the magnetic field at this location when the charge is crossing from here. So this will be given by, like, we write the formula as mu naught by 4 pi q v cross b. So that is VR sine theta divided by r cube. So it would become, this value is what? This is 10 raised to power minus 7 into charge. What would be the value of charge that is given in the question? It is found to have a charge of 10 microcoulomb. So 10 into 10 raised to power minus 6. Okay, and then V was 9,000, and then one of the R gets cancelled, so denominator is R square, so that is 1 square. The theta is 90 degree. So this number becomes what? This is 10 raised to power minus 12, so 9 nano Tesla. Okay, so 9 nano Tesla. So option D would be the correct option here. So a very good question, guys. A very unusual question. Generally, such situations are not they are not usual. So good question, I would say. You would have to figure out the value of charge, and then you have to figure out the value of velocity, and so that was a good question. That was a good question. Yeah. Okay, another good question, guys. Another unusual question, something that we have not done till now. It says that the force force in Bohr model is written as E square 4 pi epsilon naught, and then 1 upon R square uh, plus delta by R cube. Now this force will become equal to mv square by R, the centrifugal force, centripetal force, and also we have mvr equals to nh by 2 pi, the condition, the Bohr's quantization condition. Now using this we have to find out the radius of the nth orbit. Okay, so what do? We can cancel one r in this equation, like this r will get cancelled, so this will be gone and this will become square. Okay, and then this equation can be written as e square by 4 pi epsilon naught. Okay, and then 1 plus delta by r. 1 r we have taken out as a common quantity. So this becomes mv square into r. This 1 upon r is taken on the other side. Now v can be replaced from here, so it will become m into r into v square. V square would be n square h square by 4 pi square, and then m square r square. Okay, so what happens is that m gets cancelled, one r gets cancelled. Okay, so let me take this r on the other side, and also this 4 pi gets cancelled, so this 4 is gone, this pi is gone. Okay, so let me take r on the other side. So r multiplied by 1 plus delta by r is equals to, I'm taking everything else on the other side, so this is n square h square by pi m e square. Okay, and this becomes r plus delta sorry, yeah, r plus delta. It becomes r plus delta is equals to n square, what is this, h square by pi m e square. So h square by pi m e square, I think I missed epsilon naught somewhere. Yeah, this epsilon naught was here, I forgot to write it here. So this is a naught now, and I think we are done. R is a naught square, n square a naught minus delta. All right, n square a naught minus delta. Option A would be the right answer. So very good question, I would say. Unusual question. It would be intimidating for most of the students, but yeah, it's a good question. So relevant for JEE Advanced. You can surely expect such kind of question in JEE Advanced paper also. Okay, now this is a simple question, guys. There are loops which are carrying current. There are alternate loops, all right, and the direction is changing every time we are going from one loop to the next. So the magnetic field at the center would be given by mu naught I by 2r. and then the next one would be minus mu naught I by 2 times of 2r, then plus again mu naught I by 2 times of 4r, and so on. All right, so mu naught I by 2r can be taken out as the common quantity, and then 1 minus half plus 1 by 4 minus 1 by 8. So that's an infinite GP with a common ratio of minus half. So it would become mu naught I by 2r, and then 1 upon 1 minus, common ratio is minus half. So the denominator becomes 3 by 2. So this becomes 2 by 3. So mu naught I by r into 1 by 3 will be the answer. So mu naught I by 3r, mu naught I by 3r. So option C should be the right answer to this question. All right. Okay, guys. Of course, there are a large number of questions, and therefore you see me going fast. I have to, guys. Okay, now the next question says 1 mole of an ideal monatomic gas initially at a temperature T is heated in such a way that its molar heat capacity during the process. Okay, guys, now this is again a controversial question, because on one hand the question has given us the molar heat capacity, all right, and because of that, we got some property of the process. Then the question says that the volume gets tripled at constant pressure, during the process. So during the same process, now if the temperature, if the constant pressure, if the pressure remains constant, then the process becomes isobaric. And for isobaric process of carried out on a monatomic gas, the molar heat capacity cannot be this much. All right, so the question is actually contradicting itself. So if I ignore this part, if I ignore the constant pressure part, then what is the question saying? That we have done a process for which C is 2R. Now C is constant, so it's a polytropic process. For any polytropic process, C can be written as Cv plus R upon 1 minus alpha. So Cv, it's a monatomic gas, so Cv would be 3R by 2, and then, so what is the value of alpha from here? So 2R minus 3R by 2 is R by 2. All right, so 1 minus alpha should be equal to 2 if I solve this. So alpha comes out to be minus 1. All right, alpha comes out to be minus 1, which basically means that PV raised to power minus 1. PV raised to power minus 1 is constant, or in other words, P is proportional to V. So that was the process. Now if the volume gets tripled, then the pressure also gets tripled, and if the pressure and volume, they both become triple, then the product PV, that becomes 9 times, and therefore the temperature will become 9 times. So from there we are getting option B. Remember this. All right, so again, the answer key that we released, we gave 2 options as one of the as the answer. So either it can be B. If I ignore this constant pressure thingy, then it's B. Now if I consider the constant pressure thing, then it's a very simple. Pressure is constant, volume is tripled, so the temperature will also triple. So in that case, you can get A also as the answer. All right. Again, I think this shouldn't have been given, and it would have been a good question. Then it would have been a good legit question. Okay, so yeah, the answer could be A or B. I think the question is going to, like, they should award bonus for this question, or maybe they can drop this question. But yeah, either A is correct or B is correct. Okay, now again a brilliant question, beautiful question, I would say. Here there are 2 strings of equal length, all right, but the masses are different, and the question has expressed a possibility that the strings are not symmetrically placed with respect to the vertical line. Okay, so we have to find out the relation. Okay, so guys, understand this, that these particles are exerting electrostatic force on each other. Am I right? Okay, and so if I consider these particles along with the string as the system, so on the system there are forces at this point. This joint is maybe exerting some force Ny, maybe some force Nx. Okay, then the weight of these masses, m1g, this is vertical force, the m2g, this is also a vertical force, and the force that they are exerting on each other, which actually is an internal force. Okay, so the force that these particles are exerting on each other is an internal force. So the external forces would be m1g, m2g, and the normal forces. So if I write, and they are in rest, everything is at rest. So if I write torque about this point, all right, the net torque should be 0. So the torque of F will be 0. First of all, it's an internal force. If you want to write torque, then whatever torque you will calculate because of this, the exact opposite torque will come because of this. So the F is not contributing in any torque, and X and Y are also not contributing in any torque because they are passing through this point, so the torque would be zero. So the torque of M1G would depend on this distance. The string length is L, so this one would be L sine theta 1. Similarly, the torque of M2G will depend on this distance, which is L sine theta 2. So we will write M1G into L sine theta 1 is equals to M2G into L sine theta 2, and voila, we are done. That's it. This question was so simple actually. What I have learned is that many students struggled with this question. They tried to balance the forces, they resolved the forces on, they wrote the forces on one particle, resolved it, and a lot of other things was done. But this question is quite simple if you see it that way. Like M1 by M2, it becomes sine theta 2 by sine theta 1. That's it. That is your answer. So um, I guess option B. Option B is the answer that we are looking for. All right. So very simple, very straightforward question, very good question, I would say. Okay, so let's go to the next question now. Okay, now this question says that we have a parallel plate capacitor. All right, I think this is a question from the book Pathfinder. Okay, we have a parallel plate capacitor with voltage V. The area is A, the separation is D. Let's say one of the plate is fixed and the other plate is oscillating. All right, so because of the oscillations of the plate, the capacitance will keep on changing. Because the capacitance will keep on changing, the charge on the plate will also keep on changing. All right, because there is no resistance in the circuit, the charge can change abruptly. So we can assume that Q equal to CV is always obeyed. So it can be written as A epsilon naught by X, where X is the separation between the capacitor plates. All right. So we can see now that the charge will change because X is changing. So A epsilon naught V then minus 1 upon X square into dx by dt is what you get. So A epsilon naught V by this X is actually D, so D square. And so if you want to get the maximum value of current, then you should have the maximum value of dx by dt. And in an if this plate is performing SHM, then the maximum value occurs at the mean position, which is A times omega. So amplitude is small a, omega. So this is the maximum value of dx by dt. From here you can get the amplitude. So this current is given to us as I naught. So I naught into d square divided by A epsilon naught V into omega, that is the amplitude of the vibration. So id square, I think option A is the correct one. Okay, I think option A, because here there is 2, this is 2, here there is denominator 2, but I don't see any number in my expression, so option A seems to be the correct one. We can just confirm. Yeah, all right, so that is the given answer. All right, we'll now move to the next question. So we'll go to the next question now. And the next question is this: two mechanical waves given by, all right, so we've been given two equations and we can see that these are the equations of two waves which are traveling in opposite direction. We have to tell the position of the node. Okay, so how to do that? The equation of the resultant wave is given by adding the equation of the superposing waves. So we can write it as A sine of 8x minus 50t, okay, plus A sine of 8x plus 50t plus pi by 3. All right, so I'm going to use the formula for like sine A plus sine B. Okay, sine A plus sine B. So the formula for sine A plus sine B is 2 times of sine of A plus B by 2, and then cos of A minus B by 2. So this formula I'm going to use. So y is equals to, it will become 2 into A sine of sum of these two divided by 2. So when we do the sum, when we take the sum, 50t gets cancelled, divided by 2 gives us 8x plus pi by 6. Okay, and then cos and difference will give us this minus this. So 8x get cancelled and then by 2, so it becomes 50t and plus pi by 6. Okay, so this is the equation that we get. Now this part of the equation identifies the position of the nodes. Okay, so we end up with 2a sine of 8x plus pi by 6 cos of 50t plus pi by 6. So whenever this becomes, whenever 8x plus pi by 6 becomes integer multiple of pi, okay, then this becomes 0 and we get the nodes. Okay, now the question is asking us for the position of node nearest to the origin. Okay, so if I put x equals to 0, this number becomes equals to pi by 6. All right. So if x starts increasing from 0, the first time when this number can become an integer multiple of pi, starting from pi by 6, would be when this number becomes equals to pi. All right. So I will say that, okay, 8x plus pi by 6 is equals to pi. So x would be, or 8x would be equal to 5 pi by 6. So x would be equal to 5 pi by 48. All right, so this should be the value of x. Okay, so we can calculate it. Okay, we have to give the answer in terms of the centimeters. Okay, let me check. That was yeah, the units given in. Okay, so we'll do this calculation. Okay, so this becomes 5 pi divided by 48. So this comes out to be 0.327, 0.327. So this is in meter. So in centimeters, it would become 32.7. So A option would be the right answer to this question. And the given answer in our key was also option A. So that would be the right option. All right, now we'll go to the next question. The next question says, at a certain location on Earth's surface, the intensity of sunlight is this much. A perfectly reflecting concave mirror of radius of curvature capital R and aperture radius R facing the sun is facing sun to produce light of intensity 100 kilowatt per meter square at the image. Knowing that the disk of the sun subtends an angle of 0.01 radian at the Earth's surface, the relation. Okay. So we'll draw the situation. Okay, the situation is somewhat like this: that there is a concave mirror. Okay, the question talks about a mirror. Okay, and the aperture radius is given to be r. So this is 2r. This is aperture radius. Okay, and the radius of curvature is r, which basically means that the focal length would be r by 2. Okay, and let's say this is the principal axis of this mirror, and let's say this is the sun. This disk is sun. Okay, this disk is sun. So according to the information given in the question, the disk of the sun is subtending an angle, some angle. Let's say this angle is alpha. Alpha is also given in the question, so alpha would be 0.01 radian. Okay, so that is the situation. Now this uh, the image of the sun will make the same angle, alpha, and this will be formed in the focal plane. It would be formed in the focal plane. All right, which basically means that the diameter, if I say that this diameter of the image is small d, then small d would be equal to alpha into the focal length, that is r by 2. So this is the diameter of the image. Okay, so the area of the image. Okay, if I write the area of image, okay, so that area would be pi d square by 4. So that would be the area of the image. Now understand that whatever light is received by this mirror, all of that light gets focused here. So the light received by the mirror will be given by the original intensity into the aperture diameter. So this is the light received. So this is the power received. Now this power gets concentrated in an area of pi d square by 4. So this becomes the new intensity, which is actually 100 times the previous intensity. As you can see, intensity of 1 kilowatt per meter square became 100 kilowatt per meter square. So this is the equation that we want to solve. And when we start solving this, like this pi gets cancelled, this I gets cancelled. Okay, so this 4 gets cancelled, this becomes 25. So the equation that we get is small r square is equals to 25 times of d square. Let me see if there are no other things that are left. Yeah. So from here, small r is equals to 5 times of d. And what is d here? Um, so 5 times of alpha into r by 2. All right. So what are we supposed to find out? We are supposed to find out the relation between capital R and small r. Okay, so I think we are almost there. Let me go to so this becomes small r is equals to 5 into alpha. Alpha was 0.01 into r by 2. Uh, yeah. Okay, so this can be written as 2r by 5 into 100 is equals to capital R. 2 R by 5, yeah. So this will become 5, 20. So 40 R is equals to capital R. So that would be option C. So C option would be the correct one here. Okay guys, here this is not correct. C option would be correct. In the answer key that we have provided, in that answer key, the PDF that was shared, on this on the same session where we released the answer key. Uh, the answer B was depicted. We made some calculation mistake, but then later it was clarified, and the PDF it has been updated as C, so you can check it. So C would be the right answer to this question. Okay, next we'll go to the next question. Charge Q is uniformly distributed throughout the volume of a non-conducting sphere of radius r. Okay, guys, so that's a very standard thing. Again, if you're preparing for JEE advanced examination, then that's a very standard question for you. Okay, so if the this entire volume has a charge Q distributed uniformly throughout this, and the radius is, let's say, r. Okay, the radius is, let's say, r. So this will has electric field inside also, and it will have an electric field in the outer region also. All right. So there are electric field lines inside also. So basically, not exactly uniformly. That is not how it is. All right, but there is field inside also. So the energy present inside the sphere is kq square by 10r, and the energy present outside is kq square by 2r. This is also the same energy which is present outside a hollow sphere, because in the outer region the field of a solid sphere and the hollow sphere, they are identical, and the overall energy of this sphere will become the sum of these two, which will become 3 by 5 kq square by r. Now this question is asking for the energy present inside the sphere. Okay, so this is what we are talking about. So if I check it, it's kq square by r into alpha. Alpha is 1 upon 10 then. That's right. So alpha would be 1 upon 10. So clearly the answer would be option D. So this is again, guys. So there were many straightforward questions in this paper in which you were just supposed to remember the result, and these are standard results, guys. These are taught. If you are preparing for JEE advanced examination from a decent institute, this would definitely be taught. All right. So the correct answer would be 1 by 10. All right. Next we go to this question which says long straight vertical wire of cross-sectional area of radius r contains n conduction electrons per unit volume. A current I flowed in the upward direction. The expression of the magnetic force on an electron. Okay. So a long straight wire of cross-section radius r. So I'll draw this wire in the form of a cylinder like this. Okay, let the radius be r, and it contains n conduction electrons per unit volume. That is fine. Current flows in the upward direction. So I current is flowing in the upward direction. So the current would be flowing through this cross section. Now keep in mind, guys, if we are saying that current is flowing in the upward direction, then it obviously means that the electrons, they are drifting in the downward direction. And let's say they are drifting with this velocity Vd. So the current density would be I by pi r square, current per unit area. Current density is equals to NEVD. All right, that's a formula again. J is equals to NEVT. That's the formula that I'm using here. So the drift velocity of the electrons, or the drift speed of the electrons, that is I divided by pi r square into NE. So this is the drift speed. Now consider an electron which is on the surface and which is drifting downwards. At this location, the magnetic field, alright, because it's an upward, like the wire carries an upward current, so magnetic field would be like this much, and this magnetic field would be given by mu naught I by 2 pi r. Alright, so magnetic field at this location is inwards, velocity is downward. So magnetic field is inward, velocity is downward. It's a negatively charged particle, so it will face a force towards the center. Okay, it will face a force towards center, and this force will be given by QVB. Okay, it would be like QVB sine theta, but theta here is 90 degrees. So instead of V, we will have VD and charge. So E times of VD, that is I by pi r square into NE into B. B is mu naught I by 2 pi capital R. So ultimately it becomes what? This E gets cancelled. Okay, this E gets cancelled. Nothing else, I guess, it is getting. So mu naught and then I square. So I've taken care of all these things. Divided by 2 pi square r cube. So pi r square 2 pi r into n. So this, and the force would be radially inward. So mu naught I square by 2 pi r square, 2 pi square r cube n. Okay, let's see for this option. So outward is cancelled because the force is inward. Mu naught I square 2 pi n r cube, 2 pi square. So this option should be correct. So option C is the right answer, everyone. So I hope this is okay. I hope you got this. Okay, we'll now go to the next question. Moving on to the next question. Okay, now this question says, again guys, very standard thing. If you're a JEE aspirant, you most probably got it right within 30 seconds. So if we are trying to execute a circle in the vertical circle, then the minimum speed needed at the bottommost point is root 5 GL, and when this happens, the corresponding speed at these locations, like this is root 3 GL, okay, this is root 3 GL, and at the topmost point you need root GL if we are talking about a particle attached with a massless string. That's it. So answer is 3, because the question says that the minimum downward speed, so that is that we need to provide at this end. Okay, so root 3 GL. So that's very simple, I would say. So there were at least 6 to 7 questions in this paper which you could have answered within 20 to 30 seconds of reading the question if you are a good JEE aspirant. Okay, we have already done few questions. There are some more questions that are upcoming. So if you are aware of the standard result, you can straight away do the question. We have done already few of the questions. I'll keep on highlighting more such question. Another question is coming up after this one. So it says an illuminated object is placed on the principal axis in front of an equiconvex glass lens of focal length 40 centimeter, distance of 1.2. I think the similar situation was present in one of the previous question. Focal length was 40, distance was 120. I think, yeah, it was question number 19 actually. Okay, there the refractive index was given, focal length was 40 and distance was 120, and we calculated the value of V. If I'm not wrong, we calculated the value of V. I can calculate it again, but I'm just trying to point out that if you can remember the value, you can save the time. Okay. Okay, I think it was 120. 120 is the object distance. I think it was 80. It was 80. Anyways, I will calculate it again. The reflecting plane mirror has been placed behind the lens perpendicular to the... Okay, this is a good question. I think it will consume some time. So we have been given a lens. Okay, this is the principal axis. The focal length is 40 centimeter. Object is at a distance of 120 centimeter, and this is the exact same data which is given in question number 19 also. So V will be minus 120 into 40 divided by minus 80. So this would become plus 60. All right, plus 60. So the rays coming from this point, these rays are headed towards a point which is at a distance of 60 centimeter. All right, now according to the question, we have kept a plane mirror here, somewhere here, we don't know where. Let me assume it to be X, and I'm assuming it is more than 60. Like, okay, it will not matter. You can just frame your equation according to your assumptions, and then mathematics will reveal what is going on. So the rays will strike the mirror, and then they will get reflected, and it will appear as if it is coming from a point behind the mirror. Okay, so this distance, okay, uh, this distance would be x minus 60. So the image will be found at the same distance behind the mirror, x minus 60, this distance. So the distance of this from the lens is actually x plus x minus 60. So when these rays go and again pass through the lens, okay, the object would be considered at this point, and now we want that after refraction from the lens, they should appear to be coming from this point. So for this refraction on the lens, u is actually minus of x plus x minus 60, v is actually minus x, and the focal length is plus 40. So we need to put these values in the lens formula, and we need to solve. So 1 upon v is minus x, minus 1 upon u, u is minus of 2x minus 60. Am I right? 2x, yeah. Okay, and this is equals to 1 upon 40. So this is what we are going to solve. So this becomes 1 upon 2x minus 60. 1 upon 2x minus 60 minus 1 upon x is equals to 1 upon 40. Okay, so this will become x minus 2x plus 60 into 40 is equals to 2x square minus 60x. So this will become um, 2400, and then this is minus x minus 40x is equals to 2x square minus 60x, or in other words 2x square minus 20x minus 2400 equal to 0. So x square minus 10x minus 1200 is equals to 0. So this can be factorized as x minus 40 and then into x plus 30 equal to 0. So the value of x comes out to be 40. We are looking for a positive value of x, so we'll discard the negative value. So x comes out to be 40. So the distance of the plane mirror from the lens should be 40 centimeter. And now what is the question asking? The nature of the final image and the distance of the plane mirror from the lens. So 40 centimeters. So this is wrong, this is wrong. And the nature of the final image would be virtual, because of the ray diagram it is pretty evident that finally we are getting a virtual image. So this is correct and this is wrong. So A option would be the right answer to this one. So yeah guys, this was a lengthy question. This was indeed a lengthy question, and it was a question worthy of being in the JEE advanced paper, I would say that. Yeah, a question from grade 12 syllabus, ray optics syllabus, and good question overall. The good point was that the starting point of this question was same as what we had in question number 19. So I can say that maybe they saved one step for us by giving us the same data. Okay, now let's go to the next question, guys. So in the next question, okay, in the next question, again, as I said that there are few questions that have come directly from your JEE results. So, and notice that this is the second question that is coming from circular motion chapter. So when we study motion in vertical circle, we again, because we discussed this part, that if there is a block which is moving on a fixed hemispherical surface, what is the speed that we should provide it here so that it just flies off this surface? Okay, so this speed is root gr. All right, so the question is based on this situation only. The ball is kicked horizontally from the top of a hemispherical rock, and it is not hitting the rock at any point during the flight. So this velocity would be root gr, and once you know this velocity, now you can use your knowledge of projectile motion to find out this range. It's a horizontally thrown projectile, so range will be given as root 2h by g, the time of flight multiplied by the horizontal distance, horizontal speed root gr, where here h will become equal to r. So this becomes equals to root of 2r by g into root of g into r. G gets cancelled. So we get root 2 into r. So this distance is root 2 into r, which means that this distance would be root 2 r minus r, as this distance is r. So the ball will strike D, where D, this is small, this is D. Okay, so this option is correct. All right, the ball will strike at B. This is wrong. We are solving single choice correct question. So once you found out the right option, you may not, you are not required to check the other option. But just for the sake of confirmation, if you want to check, you can do that. This is definitely wrong. The speed should, so this is again wrong. So yeah, option B is the right answer to this. Okay, so again guys, another question which was framed on a direct result, which usually you know if you are preparing for exams like JEE Advanced. Okay, now the question, next question says the ratio of length, radii and Young's modulus. Okay, so length, radius and Young's modulus is alpha, beta and gamma, the corresponding ratio of the increase in length. So let's say the length of, so the figure is like this, you know, the steel block, the steel wire, and then there is a block of mass 2 kg, then there is brass wire, and then there is a block of mass 3 kg, I suppose. Yeah. So let this length be L1, let this length be L2, let the elongation in steel be delta L1, let the elongation in brass be delta L2. So delta L1 by L1 will be into Y1, okay, into Y1. Uh, okay, would be force in this string, and that force would be 5 times of G divided by the area of cross section of the string, that would be pi r1 square. Similarly, y2 into delta L2 upon L2 would be equal to, now the tension in the brass string is only because of the 3 kg weight, so that is 3G divided by pi r2 square. Now you take the ratio of these two equations, so we get delta L1 by delta L2, okay, into L2 by L1, okay, into Y1 by Y2 is equals to 5 by 3 R2 square by R1 square. So this delta L1 by delta L2, this L2 by L1, okay, so L, the ratio was alpha, L2 by L1 is 1 upon alpha, Y1 by Y2, Y1 by Y2 is gamma, then 5 by 3, R2 square by R1 square, R2, 2 is the numerator, so it would be 1 upon beta square. So we are trying to find out the ratio of the elongations, so that will become 5 by 3 into alpha upon beta square gamma. So 5 by 3 alpha upon beta square gamma. So B option looks like the correct one. So interesting question. It may look like, generally I've seen that students get confused when a lot of ratios are given and you have to deal, and the most common mistake that the students make is they fail to notice that where you know, R1 is in the numerator and where the subscript 2 is in the numerator. So I carefully placed alpha here, beta here, gamma here, beta square. So this is an area where most of the students commit mistakes. So you got to be careful while you're solving such questions. Take your time, go slow in these questions. That is the trick. Okay. Now, the question says, a uniform beam of light of intensity is incident on a totally absorbing sphere. Again, guys, a straightforward result, something that I definitely teach in my batches. If there is a parallel beam of light, and in the beam, in the path of the beam, you have kept a black body. All right. So whatever light this black body is obstructing, that will result in a force, and that force is given by the power intercepted by the body divided by C. Here it is going to be I into the area of projection, that is this area. Like if there is a shadow behind, if there is a wall, there would be a shadow on the wall, and we'll get the shadow in the shape of a disc. So the energy of this disc shaped region has been intercepted. So I pi r square by C is the force. You want to know the acceleration. So for acceleration, you will divide the force by mass. So it would be I pi r square by C into rho 4 by 3 pi r cube. So this pi gets cancelled. So this becomes 3i. Okay, r square also gets cancelled. So 3i by 4 0. Okay, so 3I by 4C rho R is the answer that we are looking for. Now let's substitute the values. I is 60 milliwatt. Okay, so 3 into 60 into 10 raised to power minus 3. Okay, then 4 into C. C is 3 into 10 raised to power 8 meter per second. This C is the speed of light into the density. Density is 5,000. Okay, density is 5,000, and then the radius of the sphere was 2 micrometer. I did not check the values with the PDF. Let me just confirm before I proceed with the, yeah, everything is okay. So the radius is 2 into 10 raised to power minus 6. So when we do this calculation, okay, let me do the calculation. So this 3 gets cancelled. If I adjust the powers of 10, okay, then it is how much? This 3 will cancel with 3 and it will become this 10 raised to power 5. Okay, let's cancel this. So 10 raised to power minus 8. Okay, so 10 raised to power minus 8. I've taken care of the powers of 10. Now this 5 into 2 will become 10, which will cancel out this 0. So 6 by 4. So 1.5 into 10 raised to power minus 8. So this is the acceleration. Now there was a discrepancy in this question. So we have 1.5 as one of the options and we have 0 as another. Now both options have a little bit of problem in them. This is a big problem in it. It is missing a factor of 10 raised to power minus 8, which could be a typing mistake. And if I consider that this value is very close to 0, then again that's problematic. Like um, some might argue that we go with the closest option. If we are not giving an exact match in the option, we go with the closest option. So if you do that, then you'll probably go with 0. And mm, if you want to, so basically A or D, depending upon uh, what school of thought you aligns yourself with. If you think that this is a misprinting and they'll probably give A as the answer in the key, go with it. And if you feel that I should give the closest match, then go with 0. If I were to select an answer from this, I'd probably, again, expressing my personal opinion, guys, I'd probably go with D, but I think our team has given answer as D. Yeah. So, all right. So that was the next question. That was question number 35 for you. We'll next go to question number 36. All right, very interesting question, guys. Very interesting question. So I'll let me the circuit might be hidden behind my figure. So there is a fuse wire, and the fuse wire has no resistance, and it is connected in parallel with a resistance. That's quite interesting. Okay, it has no resistance. It is connected in parallel with a resistance. So what are the key points that you have to keep in mind? Let me tell you that. So first thing, if there is a path of zero resistance and there is another path with some resistance and they are connected parallelly, so whenever any current will try to cross this path, it will always go through the path of zero resistance, because the current get divides in the inverse ratio of the resistance. So on one side you have zero resistance, on the other side you have some resistance. Um, so basically by putting this resistance, we have ensured that whatever current is there in this wire, it always goes through this. It never passes through 15 ohm. All right. So in this circuit, the wire will always pass, the current will always pass like this once the circuit is complete, which basically tells us that we have a zero resistance path. The inductor has no resistance, the fuse wire has no resistance, the battery has no resistance, so we have a resistance-less path. Now, when you connect an inductor in a resistance-less path and then you close the switch, what happens? So the flux in the inductor is given as Li, and this flux will begin to grow. So d phi by dt will become L di by dt. Okay, and this d phi by dt is the EMF across the inductor because there is zero resistance in the entire path. So if we go with potential distribution, like at any point in time, the potential at this point can be considered as 0 and the potential here can be considered as 10. So this d phi by dt is actually fixed at 10. So 10 is equals to L. L is given to be 5. So 5 into di by dt. So I is actually 2t. The current is a linear function of time here. All right. So the current passing through the fuse is a linear function of time, and the fuse will get burnt when this current reaches 4 ampere. So it will reach 4 ampere in 2 seconds. So 2 seconds would be the right answer. All right, good question. This question will probably confuse many because generally when you see this circuit, what you have in mind is that equation that we write for LR circuits. But the trick here is that because of the presence of fuse wire, the current is never entering the resistance. All right, so and if there is an inductor directly connected with a source of EMF, a constant source of EMF, and there is no resistance in the circuit, then the inductor gets current which is linearly increasing with time, which you might have thought it correctly, which means that after large duration, the inductor will be having infinite value of current in it. All right, but again, in reality, we don't have circuits with zero resistance, and therefore, in reality, it doesn't happen that we end up with a circuit having infinite current in it. Okay, again, guys, straightforward question. So this question is based on the concept that if there is a magnetic field, if there is a uniform magnetic field and a current carrying wire of random shape is kept here. So to find force on this wire, you need to join the ends. You need to join the ends and consider this wire as a straight wire, and then you find the force on this straight segment, and you'll get the answer. So here also we have been given a wire in the shape like this, okay, but it is kept in a uniform magnetic field. So I'm not really interested in the shape. I'm only interested in the fact that when I connect the endpoints, I get a wire like this. So when we connect the endpoints in the given figure, we get a straight wire which is parallel to the x-axis, and therefore the x component of the magnetic field will have no force. It will not cause any force. The z component will cause force. Z component is outward, so magnetic field is outward, current is towards left, so the force will be downward in the negative j direction. So any option with a positive value of j like that would be not correct. All right, and now what is the magnitude? The magnitude is BIL. So B is 4, I is given as 2.5 ampere, and the length, this length. So this length is L. This is 60. Okay, this angle is 60. This length is L. So L cos 60, twice of L cos 60. So it is L. 2 times L cos 60. Cos 60 is half. 2 times of L cos 60 is L itself. L is given as 2 meter. All right. So this is actually 2 meters. So 10 into 20. So 20 Newton force in the downward direction. So B option is the one that is correct. Okay, so B option would be correct. So that was question number 37. Okay, next we go to again standard result in a spherical capacitor. Like there are two concentric spheres. If one has a radius A, other has a radius B, the capacitance is given as 4 pi epsilon naught AB upon B minus A. Now, according to the question, we are looking for a distance R such that the energy stored within this region is same as the energy stored outside this region. So what you can do, you can imagine a third layer here. It is not present, but you can imagine this. So this layer and this layer will form one capacitor, let's say C1. Then this layer and this will form another capacitor, let's say C2. These two capacitors are connected in series. So the energy, they will have the same charge on them. So the energy on the first capacitor will be Q square by 2C1. The energy on the second capacitor will be Q square by 2C2. The two energies should be equal. So in other words, we are looking for C1 equal to C2. C1 would be written as 4 pi epsilon naught RA upon R minus A, and C2 would be written as 4 pi epsilon naught BR upon B minus R. So you solve this equation to get the value of R. When you do that, you end up with R as 2AB upon A plus B. So that would be the right answer, option C. Did you understand how to do that? The key point, the key aspect was to know this formula and then to imagine that inner region as one capacitor and the remaining region as the other capacitor. If the two capacitances are equal, then the energy stored in these two regions will be equal, and that will give you C as the answer. Okay, so guys, as I said, many of the questions are directly based on the situations that are taught as part of your JEE preparation. So again, 2-star system is given. So again, it's a standard result that in a 2-star system, like this star is of mass m1, let's say this star is of mass m2, this is the center of mass. So m1 will go in a circle like this, m2 will go in a larger circle, okay, and they will always stay like this. So they will have the same omega. All right, they are both moving with the same omega. And how do we write this omega? This omega is root of g into sum of masses divided by cube of distance between them. This is how we write it. Okay, so in the given question, the omega is root of g sum of masses. Sum of masses will become 16 times the mass of sun. Okay, and then the distance between them is 4 times the astronomical unit. Okay, so 4 AU cube. Okay, so this becomes what? This becomes root of g into 16 by 64. That is 4 times of ms by AU cube. Okay, so this 4 can be taken out of the root. So root of gms by 1 AU cube. This is what? This is actually omega of earth. So this is half into omega earth. So earth is going around the sun with an angular velocity of omega earth. This binary star system is moving with an angular velocity which is half the angular velocity of the earth. So if the angular velocity is half, then the time period would be double. So if earth takes 1 year to complete one circle around the sun, this binary star will take 2 earth years, 2 earth years to finish one circle. So the time period would be 2 years here. Okay, so the time period would be, so if you know this result, everyone, if you know this result, the question is easy, it's doable within the stipulated time frame. If you don't know this result, then a lot of derivation is needed. So one thing that you can clearly understand from the solutions that I'm doing is that when you prepare for an exam like NSEP, you need to learn a lot of formulas. All right, many times I've seen that intelligent students have a resistance to learning the formula. They believe that they can derive the formula as and when needed. All right, this assumption is flawed. I'm not saying that you can't derive. I'm saying that you can't waste your time in deriving the formulas. It's like that I'm asking you to participate in a race and you are saying that, sir, I will start from the starting point. I'm saying that no, you should not, you need not start from the starting point. You can actually start, 2, 3 steps ahead by learning the formula. You can save that 2, 3 steps. You can directly start with the formula and solve the question, but you are saying, no, sir, I will derive it first. So that kind of attitude actually is detrimental for you if in case of exams like NSEP, which requires tremendous speed. Okay, now again, this question is a controversial question because here the mass is given as 226 as part of the symbol, but here it is written 116, which creates confusion. So we get two different answers with the two different values. I'll go with 226 and I'll present my solution. So again, there is a controversy in this question. I don't know how will they resolve the controversy, but let's see. So if there is a particle that undergoes alpha decay, all right, so the daughter nucleus goes opposite to the direction of alpha, and if the Q value, the kinetic energy of the alpha particle is given as A minus 4 by 4 into the Q value. Again, this is a standard result that I'm using. So the kinetic energy of the alpha particle would be 222 by 226 into the Q value, which is 4.9 into 10 raised to power 6 into 1.6 into 10 raised to power minus 19 joule. So this is the kinetic energy of the alpha particle. And if we are looking for the, so the question says energy of recoiled daughter nucleus is this much, energy of the recoiled daughter, and then the recoil speed of the daughter nucleus, speed of the, so two of the options talk about the energy, two of the options talk about the speed. So let's first figure out the energy thing. So the kinetic energy of the alpha particle would be this it would be triple two divided by 226 into 4.9, so that's 4.81. Okay, so kinetic energy of the alpha particle is 4.81 MeV. Okay, MeV, this is the kinetic energy, and therefore the kinetic energy of the daughter nucleus would be Q minus K alpha. So it would be this minus 4.9, so it would be 0.086 MeV. So these are the kinetic energy. So energy of the recoiled daughter nucleus is 8.7 keV. Here it is keV, guys. Okay, let me check in the PDF. It was keV. So let me express this in keV. So it would be 86 keV. I'll multiply with 1000. So this option is not correct. Kinetic energy of the recoiled daughter nucleus is nearly, so again this is not correct. Energy of the recoiled daughter nucleus, yeah, this is not correct. Now recoil speed of the daughter nucleus and speed of the alpha particle. So let's first find out the speed of the alpha particle because I'm ready here. So I will write half into mass of alpha particle, that is 4 AMU, okay, into V square is equals to um, this is 4.81, okay, so 4.81 into 10 raised to power 6 into 1.6 into 10 raised to power minus 19 joules. From here we are going to get V. So my planning is to write V as root of 4.81 into 10 raised to power 6 into E. E would be present in my calculator as a, as a value, divided by this AMU is what? This AMU is actually mass of a proton. Okay, so this is the calculation that we need to do. 4.81 into 10 to the power 6 into E divided by 2 times the mass of proton, and then we'll take the root. So let me finish this calculation. So 4.81 into 10 raised to power 6 into the value of E. So the value of E, okay. So we've got this. Now we are going to divide it with 2 times the mass of a proton. Okay, 2 times the mass of a proton. So we have done that also. And then we'll take the root of this and we'll end up with this is 1.5 into 10 raised to power 1, 2, 3, 4, 5, 6, 7. 10 raised to power 7 meter per second. So let me check the option now. All right, so the option differs by a factor of 10. So 1.5. So this is not correct. This is not correct. Now option C is remaining. Ideally, I have eliminated 3 options, so C option should be correct, but we don't know. There could be an erroneous question also. There had been many in this paper already, so let's check it out. So how do I find the recoil speed of the daughter nucleus? So I found out the speed of the alpha particle, and I know that mass of alpha into speed of alpha would be equal to mass of daughter into the speed of daughter. So the speed of daughter would be speed of alpha into mass of alpha, that is 4 AMU divided by 222 AMU. All right, so whatever speed we have got, we multiply it with 4 and then we divide it with 222, and this gives us 2.73 into 10 raised to power 1, 2, 3, 4, 5. 10 raised to power 5 meter per second. So 2.73, 2.74, that is good. Yeah, this option is matching, thankfully. So option C would be the right one. All right, again guys, option C would be the right one. Okay, option C is the right one. Okay, and again, this question is controversial because if some student tried the question with 116 AMU as the mass, then they would have faced a lot of problem because none of the options would have matched. Okay, so that was question number 40. Okay, we now go to next question. Now this question is based on Doppler's effect. Okay, so in this question there is a source which is traveling eastward. Let's select this as the east direction, this as the north direction. So it is traveling, and this is traveling with a speed of 15 meter per second, and here is a stationary observer. He hears the frequency f1. So f1 would be written as f into c upon c minus 15. So that is first equation. Next, this observer also starts traveling with a speed of 25, I believe. Yeah, and now he hears the frequency f2. So f2 would be given as c plus 25 upon c minus 15. The value of c is also given to us. Now the difference of these two frequency is given as 40 hertz. So when I take the difference, f by c minus 15 can be taken out as the common quantity, then c plus 25 minus c, so only 25 will be there. Now we calculate this. So 45 by 25 is 8 by 5 is equals to f upon c minus 15. So we are looking to find out the value of f. F would be 1.6. 8 by 5 is 1.6 into c minus 15. C is 340. 340 minus 15 is 325. So 325 into 1.6 will give you the answer, and this is 520 hertz. So straightforward question. Okay, so 520 would be the right answer to this one. A question on Doppler effect, grade 11th topic. Yeah, this could be asked in JEE Math. All right, next question. It says a uniform rod of length L swings from a pivot as a physical pendulum. The position of, okay, again, as I said, guys, standard results. All right, so again, this is based on, so if you are using any object as a physical pendulum, you have suspended this object from a point, from a pivot, and you're using it as a physical pendulum. The center of mass is at a distance L. Okay, then um, the omega is given as root of mgl by I, where I is the moment of inertia. Again, I'm mentioning the result, guys. It's not that I'm explaining, like I'm mentioning the result so that you can know a few things. Now this can be written as mgl divided by I, can be written as ICM plus ml square. Okay, and then ICM can be written as mkcm, where kcm is the radius of gyration. Okay, so from here you see that m gets cancelled and we get g divided by kcm square by L plus L. All right, so this entire thing is called the effective length. So effective length is kcm square by L plus L. All right, and from here we can also discover that when we put L equal to kcm, at that time we get the minimum time period. We get the minimum time period. So again, this is a standard result. If you are aware of that, you can straight away get the answer. For a rod, kcm is L by root 12, and that is going to be the answer. So if you're aware of these standard results, you see you can save so much of time. Okay, so this is marked incorrectly, guys. I think the correct answer to this question, as provided by us in our key, is option D. All right, so guys, this whatever we have in typing here, this has not been verified by anyone. I am straight away using it for recording, and therefore you see some typing errors here. Okay, now the question from semiconductors topic. Um, like this topic is not part of JEE mains anymore, I think so. Okay, anyways, uh, so the question says that at room temperature the number density of conduction electron is this much. The number density of the conduction electron is increased by a factor of this much. That means the final number density is 10 raised to power 16 multiplied by 10 raised to power 6, so that is 10 raised to power, so this is the final value. Okay, uh, every phosphorus atom contributes one electron to the, so see, after doping this is the number density we are getting. Before doping there was different, so after doping and before doping what we are getting, all right, the difference would be the contribution from the phosphorus atoms. So 10 raised to power 22 minus 10 raised to power 16 is almost 10 raised to power 22. So understand that this number that we've got is actually the density of the phosphorus atoms. All right, so what I'm saying is that in 1 meter cube, we have 10 raised to power 22 atoms of phosphorus. Okay, so this is what I'm saying, phosphorus. Okay, now in 1 meter cube, let's think about silicon now. In 1 meter cube, the density of silicon is given. Okay, so in 1 meter cube, we would have 2330 kilograms of silicon. So these many grams of silicon. So if I divide it with the molar mass of silicon, which is given to be 28.1 gram. So this is in gram, this is in gram. Now it is moles. So in 1 meter cube, we have these many moles of silicon. So we have these many atoms of silicon. So the number of atoms of silicon in 1 meter cube, that would be given by 2330 into 1000 divided by 28.1 and then multiplied by Avogadro's number. How much is that? Multiplied by Avogadro's number. Okay, so this is coming out to be approximately 5 into 10 raised to power of 28. So these many atoms of phosphorus are there, these many atoms of silicon are there. We are trying to calculate the ratio, the fraction of phosphorus atoms. So just take the ratio. So 10 raised to power 22 divided by 5 into 10 raised to power 28. So that's 0.2 into 10 raised to power minus 6. Okay, or 2 into 10 raised to power minus 7. So B option would be the right one. All right, B option would be the right one to this. Okay. Yeah. Yeah, this is a good question, guys. A question on surface tension and electricity combined. So we have a air bubble. We have a air bubble. The thickness of the bubble is given. So this radius is given, and this thickness is given T. So the volume of the liquid which is constituting this bubble is 4 pi r square T. Okay, now this bubble condenses into a droplet of radius r. So the volume of the liquid from this drop is 4 by 3 pi r cube. So capital R is actually r square T raised to power 1 by 3. Okay, this is what we found. Now, uh, there was some charge present here, let it be Q. Okay, so because of that, the potential of the bubble was kq by small r. Okay, kq by small r. Now the same charge will be present on this droplet, and the solution is given to be conducting. So the charge will appear on the surface, and therefore the new potential will be written as kq by capital R. So v prime by v, k gets cancelled, q gets cancelled. V prime by v would be small r by capital R. So small r by capital R is this value. We have already calculated capital R. Okay, so this becomes what? This is r cube. So this is r. I think I've missed out on something. Yeah, 4 pi got cancelled, so 3 was still there. So there would be a 3 also. There would be a 3 also. Okay, so here also there would be a 3 also. So this will become r upon 3t and then 1 upon 3c. Okay, so now you just substitute the value. So v prime is small r. How much was small r? 10 centimeter. Okay, so 80 volt. Okay, so v is 80 volt, and then small r is 10 centimeter. I'm keeping everything in centimeter. 3 into thickness. Thickness is 10 by 3. 10 by 3 into 10 raised to the power minus 6. This is also in centimeter. Centimeter gets cancelled, and then power is 1 by 3. So we'll finish this calculation. This gets cancelled, this gets cancelled. 10 raised to the power minus 6 becomes 10 raised to the power 6, cube root of that. So this becomes 8000 volt. So D option is the correct one. Alright, I hope you got that, everyone. Okay, so D option would be the correct one here. And now we'll go to the next question. Okay, so in this question we have been given one resistance like this, one resistance like this, and then one resistance like this. So the equivalent of this portion is actually R by 2, and then we have R resistance in series. So if I apply a voltage of V across this combination, okay, this V will get divided into two parts. Let's say this one would be V1 and this one would be V2. Because they are connected in series, voltage will get distributed in the direct proportion of resistance, which means V1 can be written as R by 2 upon R by 2 plus R into V. So that would be R by 2, so that would be V by 3. Alright, and V2 would be equal to 2V by 3. So we can clearly see that this resistance is getting more potential difference across itself. So this resistance has more chance of getting damaged. So if I go back to the original circuit, if we apply V potential difference on this combination, this will have 2V by 3 across itself, and these two will have V by 3 across itself. Okay, so between the three, among the three, this has chances, like this has more potential difference across it at any instant of time, so this has more chances to get damaged. Now how much potential can it tolerate? That is given here. The resistance is 4 ohm and they are rated at 16 watt. So so if I apply a potential of V, alright, so V square by 4, V square by R equal to 16. So the maximum potential that they can tolerate is 8 volt. You know, V square is 64. So maximum they can tolerate is 8. So this R is getting exposed to 2V by 3. So when 2V by 3 becomes equals to 8, this R will get damaged. So V is 12 volt. So this entire combination can tolerate a maximum potential of 12 volt. When you apply 12 volt across this combination, this R gets 8 volt across it, which is the maximum that it can tolerate. So coming back to the options, um, statement 1 says maximum potential difference V that can be applied is 12 volts. So statement 1 is correct. Statement 2 says maximum power that can be dissipated. Now, guys, the equivalent resistance here is 3R by 2. Alright, so equivalent resistance is 3R by 2 and R is given to be 4 ohm. So 3 into 4 by 2, that's 6 ohm. So the entire combination is behaving as a 6 ohm resistance and we have applied 12 volt across it. So the power that will be dissipated would be V square by R, so that would be 24 watt. So statement 2 is also correct. So both statements are correct. So option D would be the right option here. Okay, so this one would be right. So that was question number 45th, a straightforward current electricity chapter question. This question can well be asked in NSEP exam also, like it is not very complicated, and yeah, it can be asked. Okay, again, very standard question, guys. We know that in any cylindrical container, if you put a liquid and you start rotating the liquid, the profile that we get is parabolic. This is standard knowledge. If you have studied fluid in detail, or in sufficient detail, not in very drastic details, you would know that the surface would be a paraboloid. So again, one of those questions that I was saying that you can just read the question and you can mark the answer because the standard data is there in the questions. Okay, so this is one. Again, this is something which is standard result. So you have a sphere, of uniform density, like uniformly distributed charge in it, and then if you make a cavity, a spherical cavity in it, this part is all solid, then what about the electric field in this region? The electric field is uniform, all right, and assuming that the charge is positive, this electric field is directed along the line joining the two centers, so it would be a uniform electric field. So parallel straight lines, field lines, so it is a uniform electric field like this, and the value of this electric field is actually rho into the CO distance, rho CO by 3 epsilon naught. So if you want to write it in vector form, this is how you can write it. So again, guys, this is a standard result which has been used here. Okay, so the electric field at any point inside the cavity would be uniform. Okay, so you see, no, this radially, it's incorrectly marked, guys. It's incorrectly marked. This is correct. Okay. So as I said that there are at least 6 to 7 questions that you could have just read and answered. I think it will make a lot of difference to the marks of student who actually were able to reach to these questions and were able to mark these questions just by reading the answers, just by reading the options. So that would have significantly boosted their result. Okay, again, something which is again taught as part of JEE Advanced. That this is certainly taught as part of JEE Advanced preparation only. This is not taught as part of JEE Mains. So there is a container and it is filled with a liquid. Okay, and if you make a hole in the container and the size of the hole is very small as compared to the area of the container, so liquid comes out of it with a velocity which is given by root 2 gh, where h is this height. Now when we calculate the rate at which this height is falling, this level is falling, all right, like if we try to calculate the time of fall from h1 height to h2, this time is some constant into then root of h1 minus root of h2 is what we get. Okay, we can derive the exact result, but the question has given us enough information to work without this. We can eliminate this c. So the question says that it required, see, this condition is given. Okay, it required how much time? T time. Okay, T time to empty the tank from h to h by 2. So T is equals to C and then root h minus root h by 2. Now let's say if T prime is the time required to fully empty the tank from h by 2 to 0, then I will write it as C into root of h by 2 minus 0. So T prime by T will become, when we take the ratio, C gets cancelled. So it will become root h by 2 divided by root h minus root h by 2 So root h gets cancelled from everywhere. Let's multiply numerator and denominator by root 2. So 1 upon root 2 minus 1 is what we are going to get. You can rationalize this. You can rationalize this. And when you do that, you get root 2 plus 1 upon 1. So t prime would be t times of root 2 plus 1. So option D would be the right answer here. All right, option D would be the right answer. So that was question number 48 for you. All right, so we'll now move on to the multiple choice questions. All right, we have done the 48 single choice questions. You could see that about 6 to 8 questions were there which could have been done, which we can do very easily if we know the standard results. All right, so speed is all about knowing the results. All right, okay, let's move on to the MCQs now. So, moving on to MCQs, the question says, according to Bohr theory, in ground state of hydrogen atom, an electron revolves in circular orbit of radius r with velocity v, circulation frequency f. Magnetic dipole moment of the electronic orbit, okay. Magnetic field, okay. All right, guys. So first we need to write a few things. So in a hydrogen atom, the radius is given by 0.529 angstrom, okay, and then we have n square by z. So we can say that it is like some constant r naught into n square by z. When we try to write the speed of the electron in the orbit, we get 2.18 into 10 raised to power 6 meter per second into z by n we get. So again we can write it as v naught into z by n, and from this we can get omega. Omega is v by r. So it would be some constant omega naught, and then when we write v by r, so it would be z upon n divided by n square into z. So it would become omega naught into z square by n cube. All right, and if you are trying to calculate the magnetic dipole moment, so the magnetic dipole moment, it is said P. So magnetic dipole moment is actually, it's only dependent on the orbit number. This is again a part of theory. So it is n times of the Bohr magneton, okay. So it only depends on the orbit number, okay. And if you are trying to calculate the magnetic field, then that magnetic field can be written as mu naught I by 2 pi r, where I can be written as, I'm doing it on the next page, I can be written as mu naught, then charge into omega, omega by 2 pi, this is I, divided by 2 pi r. Yeah, okay, no, pi is not there, pi is not there. It's a circular orbit, so pi will not be there. So mu naught I by 2r, okay. So it will become mu naught into E by 4 pi, mu naught into E by 4 pi, and then omega by r. So omega by r will become omega naught into z square by n cube divided by r naught n square by z. So n square by z. So it will become again some constants into z cube by n raised to power 5. So once we have prepared these formulas, then we can attempt the question now. So now we are talking about a helium ion. So for helium, helium plus z will become equal to 1, okay. No, z represents the atomic number, so it would be 2. Z will be 2, and we are talking about the state n equal to 2. So Z and n, they are both equal to 2. For the entire discussion that we are having, Z is equals to 2, n is equals to 2. Now the radius of the orbit. So in the radius, if I substitute, it will become 2 square by 2, so 2 times of r. So this is correct. Okay, this is correct. Then magnetic dipole moment. Magnetic dipole moment only depends on the orbit number. So we are talking about second orbit, so this is also correct. The frequency, okay, frequency would be proportional to omega, okay. So like frequency can be written as f naught into z square by n cube. Z and n, they are both equal to 2, so it becomes f by 2, okay. So this is also correct. And then the magnetic field at the center. So magnetic field at the center, it's z, so 2 cube upon 2 raised to power 5, so that would become 1 upon 4. 1 upon 4. So yeah, this is also correct. So for this question, all 4 options are correct. All right. So you see how we figured out all the 4 options. That is how you need to do this question, guys. Good question, I would say. Good question. Like in terms of the time it will require, it would have consumed. It's a good question. Now the next question is based on what we call as equilibrium. Okay. Uh, yeah. Okay, so a potential function is given to us. Potential function is given to us as minus 100x and then x square plus 4. This is the potential function given to us. Using this potential function, we can find force. Force would be given by minus du by dx. So there is already a minus sign here. So we got rid of the minus sign. Then when we differentiate, 100 will come out as the common quantity. I'll start differentiating. It's x square plus 4. Derivative of x will become 1. Then minus numerator into differentiation of the denominator, that is 2x, divided by square of the denominator. All right, so this becomes 100 into 4 minus x square upon x square plus 4 square. So let me write it again. So force that we are getting is 100 multiplied by 4 minus x square upon x square plus 4 square of this. Now you have got the expression for force. Now let's read the option. So first option says that force acting on the body at x equals to 0 is 25. So if I put x equals to 0 here, all right, f at x equals to 0, I get 100 into 4 divided by 4 square. So yes, it is 25 Newton. So this is correct. Okay, then there is a stable equilibrium. So guys, at equilibrium position, force will become 0. So when I equate force to 0, I get two value of x, plus 2 and minus 2. So these are certainly equilibrium positions. Now whether they are stable or not, that we have to check. So if I want to check x equals to 2, let's say, what will I do? If I substitute x as 2 plus something, anything more than 2, then we will end up with a negative value of 4. So at x equals to 2, if I take the particle a little beyond x equals to 2, we get force in the negative direction. If I put x as something smaller than 2, then we get a positive value of force. So yeah, x equals to 2 would be stable equilibrium. X equals to 2 would be stable equilibrium. So this is correct. Similarly, if I want to check for x equals to minus 2, all right, if so this x equals to minus 2 is this, let's say, if I take it somewhere here, somewhere to the right of this point, so x will now become minus 1.9, kind of, minus 9, 1.99 maybe. So when this happens, when you put this value here, you get a positive value. You get a positive value of force, which means that the force will be in this direction. And when you substitute x as 2 point minus 2 point something, you will get a negative value of force. So yeah, it is unstable, because if we shift rightward from this position, we get a rightward force which will take the particle away. If we shift leftward, we get a leftward force which will again take the particle away. So it is unstable equilibrium. So even this part is correct. Even this part is correct. Okay. Now the body executes small oscillations with angular frequency. So first of all, the body can execute small oscillations only about the equilibrium position, only about the stable equilibrium position. So we must be discussing oscillations about x equals to 2. All right, and to know about the angular frequency, what you can do, force you have found out as 100 into 4 minus x square upon 100 plus x square. So if x is tending to 2, all right, I can write x as maybe I can write x as 2 plus epsilon, where epsilon tends to 0. So epsilon indicates small displacement from the position of x equals to 2. So this force expression now becomes 100 into 4 minus 2 plus epsilon square upon 100 plus 2 plus epsilon square. Okay, I think there was a square here also in the expression for force. Yeah. Okay. Yeah. So 100 and then I can take 4 as the common quantity. 4 will be taken out as the common quantity, so it will become 1 minus, and then 1 plus epsilon by 2 whole square. I will apply the binomial theorem, so it will become 1 and epsilon by 2. Epsilon by 2. So minus epsilon only. I've done some calculations here. So 2 I've taken out as a common. So 1 plus epsilon by 2 square, and then when you apply the binomial, it becomes 1 plus epsilon. So that is what I've done here. And the denominator, again in denominator, it will become 100 plus 4. 104 square. Okay. So this will become 400 divided by 104 square into epsilon. So this can be equated to m omega square epsilon. So what we are looking at is, let me do the calculations here. The omega would be, how much was the mass? 0.25. Okay, so 0.25 can be written as 1 upon 4. It will go on this side. So 1600. Okay, 1600 divided by 104 square. Okay, and root of this. So omega comes out to be 0.384 radian per second, and the option is talking about angular frequency of 0.5. So this is not correct. The angular frequency that we are getting is 0.384. So this will not be correct. Option A, B, C would be the right answer to this one. All right, so that is the next question. Now this is a good question. Okay, it says uniform rod OA of length L is freely pivoted at one point. Let C be the midpoint. Choose the correct statement. So there are some options given. Rod can perform small angular oscillations. So if we we are trying to use this rod as a physical pendulum, and we talked about a physical pendulum in one of the previous questions as well. The omega is given as root of mgl by I. Okay, now L is the distance of center of mass from the axis, so that will become L by 2, and moment of inertia about the axis, that will become ml square by 3. Okay, so it becomes root of 3g by 2L. Now the question is talking about time period. So time period would be 2 pi by omega. So 2 pi root of 2L by 3G would be the time period. Okay, so this option will not be correct. This is not the correct option. Now next, rod is brought to horizontal position, then released. The angular velocity of the rod when it is, so now we can use the energy equation. So the rod was released from this position. Okay, and then it becomes vertical, and when it becomes vertical, it is traveling with some angular velocity, let's say theta dot. Okay, so the center of mass has fallen down by a length L by 2. So the loss in gravitational energy is mg L by 2. This has become equal to the kinetic energy. So this is half into I. I is ml square by 3 into theta dot square. So from here you can get the value of theta dot square as like this. Half gets cancelled, m gets cancelled, L gets cancelled. So it is 3g by L. Okay, it is 3g by L, and then theta dot will become root of 3g by L. So what does the option says? This is correct then. This is correct. Now when the oscillating rod comes to the vertical position, it breaks at point C without generating any impulsive force. When the oscillating rod, okay, when the oscillating rod comes to the vertical position, it breaks at point C without generating any impulsive force. The largest angle from vertical reached by the upper part OC of the rod is, okay. Now I think it's the option C is the continuation of what we have studied in option B. So from this position, this part gets broken without exerting any, there is no interacting force between the two parts, it just gets broken. So when it happens, the center of mass of the broken part, okay, the center of mass of the broken part would be this point. It would be traveling with speed. This speed would be how much? This speed would be theta dot into this distance is going to be 3L by 4. So this point will get projected like a projectile, and a horizontal projectile will ensue, and the rod will keep on rotating with the same angular velocity theta dot. All right, it was having anti-clockwise rotation, so the rod will keep on rotating anti-clockwise, and this kind of motion will ensue for the fallen part. What about this part? So this part will have some kinetic energy with it, and that will because of that it will continue its motion. Maybe it will acquire some angle beta, and then it will instantaneously come to rest, and it will again go in the opposite direction. So we are trying to find out the value of beta. So for that, I would first like to know what is the kinetic energy in this part of the rod, in this top half of the rod. So I know the omega. So the kinetic energy in the top half of the rod would be half into the moment of inertia of the top part. The mass of the top part is now m by 2. The length is now L by 2. Okay, so half ml square by 3. This is the moment of inertia, guys. Okay, this is the moment of inertia of the top part only, about the axis, so half ml square by 3 into theta dot square. Theta dot square was 3g by L. Okay, so this is the kinetic energy that the this top part is having, and if the rod goes till angle of beta, then the height by which the center of mass has risen, okay, the height by which the center of mass has risen, this height is like, again, mass of this part is mg. This height can be written as, this is what, L by 4. L by 4. So L by 4 into 1 minus cos beta. So from here we'll get the value of beta. Let's start solving now. So this becomes how much? This 3 I can cancel it from here. G I can cancel from here. Okay, this m by 2 entire thing can be cancelled from here. So L can be cancelled from here. So this becomes 1 by 4 is equals to L by 4 into 1 minus cos beta. Okay, so 1 is equals to, did I miss out on anything? Let me just check for once. I actually missed one thing. Square, it would be square, ml square by 3. So there is one factor. In fact, the dimensions were not matching. That got me concerned. So L by 2 is still there. So this L by 4 gets cancelled. So half is equals to 1 minus cos beta. So cos beta is half. So beta is 60 degree. So if I go back to the options, this is again correct. And after breaking the lower part, just falls vertically rotating about the center. No, that is not correct. It doesn't falls vertically. It goes as I described. So option B and C would be the correct option for this question. Okay. Now this question says a boy standing on a stationary ice boat on a frictionless horizontal flat iceberg. Okay, guys. So in this question, what is the result that you want to use? So let's say if there is a gun of mass m from which you have to shoot a bullet of mass m, and the muzzle velocity is given. So the muzzle velocity is velocity of the bullet with respect to the gun. So after after we have shot the bullet, let's say this is traveling with speed v1 in the ground frame, this is traveling with speed v2 in the ground frame, and the muzzle velocity, that is the relative velocity between these two, okay, that is, let's say, v. Okay, this is capital M, this is small m. So v1 will be written by capital M upon m plus m into v, and v2 is written as small m upon m plus m into v. So this is the velocity that we get because of the jerk, the explosion. Okay, so we have to use this formula repeatedly. Okay, I'll show you how. So the situation is, let me draw the situation. A boy stands on a stationary fraction of the, so the combined mass of the boy and the boat is 60. So let's say this is the plank in the shape of a boat. The boy is present here, and their combined mass is 60 kg. Now this boy is having two balls of mass 10 and 20. So it has two balls, one of mass 10 kg, the other of mass 20 kg. So this is 10 kg, this is 20 kg. Okay, are placed on the boat. In order to get the boat moving, he throws the ball backward horizontally, either in section or both together, and the relative speed is 6 meters per second. So muzzle velocity is given to us. Okay, now A option says that when both the balls are thrown together. So when both the balls are thrown together, it is like we have shot a bullet of mass 30 kg and the gun has a mass of 60 kg. Are you getting it? The boy and the boat, they become the gun. The sum of the two masses becomes the bullet. The relative velocity is 6. The relative velocity is 6. So the velocity acquired by the gun, all right, it would be written by the velocity of the mass of the bullet divided by the total mass into the muzzle velocity, that is the relative velocity. So it will become 2 meter per second. So option A is correct. All right, option A is correct. Okay, when both the balls are thrown together, so this is definitely incorrect because it contradicts option A. 2.17, when the balls are thrown one after the other, first M1. All right, so if we are throwing M1 first, then the mass of the bullet is 10 because M1 is the bullet now, and the total mass is the mass of the bullet plus the mass of the gun. The mass of the gun is now 80. Mind it, this 20 kg is still on the board, so the mass of the gun is 80. So this into 6. So this is the speed that that the boat will acquire after throwing M1. Now, as a result of throwing M2, additional speed will come. How much will that speed be? So when we throw M2, the mass of the bullet is now 20, and the total mass now was 20 plus 60. It was 80. All right, the 10 kg was already thrown. So when the man threw the 20 kg ball, then the total mass was 20 plus 60, and this was thrown with a speed of 6. So how much does this become? So this is what? 6 by 9, 2 by 3. 2 by 3 is 0.67. And this is what? 6 by 4. 6 by 4, 1.5. So 1.5 plus point. So this is actually 2.17. So this option also seems correct. This is correct. Now D option will be solved in a very similar manner. Now this time we are first throwing M2. So if you are first throwing M2, so your bullet mass is 20, total mass was 90, relative velocity was 6. Then when you threw the second ball, like the second time you threw the 10 kg ball, so the bullet mass was 10. Now the total mass was 10 plus 60, that is 70, and the relative velocity was 6. Calculate this. So this gets cancelled. So this becomes 2 by 3. So 4 by 3, 1.33 plus this is 6 by 7. Okay, so 1.33 plus how much is 6 by 7? That is 0.85 something. Let me do it. 6 divided by 7 is 0.857. Okay, 0.857, and if I add 1.33 to it, okay, then it becomes 2.19. So I think even D option is correct. All right, so A is correct, C is correct, D is correct. All right. So the same formula that we used to check all the 4 options, but a good application of the formula and good practice, to learn that how every time that throwing event occurs, the boat receives an impulse, and what is the consequence of that impulse on the speed. It's a good question to actually demonstrate that. Okay. Again, I think there is going to be controversy over this question. Although there shouldn't be any controversy, like given the language of the question, the options are pretty clear. The point is that given the language of the question, we get only one option correct, which is kind of generally I would not expect, single option. It's not like that. It cannot be like that. It can be a single option correct also. Let's discuss and then we'll talk. So we know that in this circuit, eventually the current becomes equals to E by R. So the final current has no, the inductance has no implication on the value of the final current. Okay. So here, first of all, the graph given does not clarifies whether this second graph reaches the same asymptote or not. But we will assume that it is reaching the same asymptote. Otherwise, we'll not be able to conclude anything. So the final current is same. So that means that E by R is same. E by R has got to be same. But the growth of current has slowed down. So the time constant is written as L by R. So this L by R, if the growth has slowed down, then the time constant must have increased. So this L by R ratio must have increased. So what we can conclude from the graph is that E by R is constant. We are not saying that E is constant or R is constant. We are saying that their ratio is constant. So there might be a situation that both have become half. And then L changed correspondingly to ensure that L by R has increased. The time constant has increased. So this is what we can conclude. The question says, what are the conclusions that we can draw? So we can't conclude that E and R are unchanged and L has increased. It is one of the possibilities. It is one of the possibilities that E did not change, R did not change, and L increased. But we can't conclude that E and R were unchanged and L was increased. We can't make that conclusion. So the conclusions that may be drawn, the conclusion is that E and R, E by R ratio is unchanged, but this ratio has increased. So this is the conclusion that we can draw. We cannot draw a conclusion. C conclusion, E by R is unchanged, but so this is definitely wrong. So it is not, it is neither a possibility nor a conclusion. Stored magnetic energy has increased. Again, we can't draw that conclusion that stored magnetic energy has increased because E by R is constant. The conclusion that we draw was that E by R is constant. So stored magnetic energy is half Li square. Okay, so I is same, final I is same, and we can't make that conclusion that energy has increased. It could decrease also. For example, if we have decreased the value of L, we have decreased the value of R more, significantly by a higher factor, then this L by R will increase. So, and we can manage to keep this ratio same by managing E. So no, we can't conclude that the energy is increased. So the only conclusion that we can draw is option B. And here is where I think the controversy may be there. Like some of the institutes, some of the teachers may give possibilities as the conclusion, which would be wrong, right? If the question clearly mentions conclusion, not the possibilities. Okay, so I'm expecting, but again, if the examiner thinks otherwise, or if the examiner himself used the word conclusion without paying attention to the fact that probably he wanted to ask the possibilities, then there would be a mismatch in what I am telling and what you will see in the answer key. But according to me, B option is the right option, and the only B option is the right conclusion to draw. That's the conclusion to draw. There may be other possibilities, but the conclusion is option B. What we can conclude was only option B, and that would be my answer. Okay, guys, so that was question number 53. Okay, that was question number 53. Now we move to question number 54. Okay, so what does okay, where does the question should, okay, so Earth is revolving around the Sun in a circular orbit of radius r with a period of revolution t. Suppose that during the revolution Earth at any instant the mass of the Sun instantaneously becomes double. Okay, so let's try to understand. uh, Earth is going in a circular orbit of radius r, which means the speed that Earth would be having would be root gms by r. All right, and ms mass is present here. Now the question says that the mass of the Sun instantaneously becomes 2m. So now that would mean that the circular orbit would require a speed of g into 2ms by r, but the speed was less. So the Earth will no longer continue on the circular trajectory. What we see here is that the speed of Earth is less than the required speed for circular motion. So it will enter into an elliptical trajectory with the point, this point being the apogee. So it will enter into an elliptical trajectory like this. Let this be r dash. So how do we calculate r dash now? So you know the speed at this point v, you know that. So this speed can be written as root of 2 times of g into the mass. Now mass is 2m. Keep in mind mass is 2ms. Okay, divided by r dash plus r multiplied by r dash by r. Again, that's a formula that you should be, and you solve this now. You should be knowing this formula, and you solve this now. And so gms gets cancelled, gms gets cancelled. R gets cancelled. We can remove the root sign also. So what we are getting is that 1 is equals to 4 r dash upon r dash plus r. So r dash plus r is equals to 4 r dash. So r dash is equals to r by 3. So this is what you are getting. Now the question says the period of, so now see we want to talk about the period of revolution, so we need to pay attention to the length of the semi-major axis. Length of the semi-major axis would be r plus r dash by 2. So that would become r plus r by 3 by 2. 4r by 3 by 2, so that's 2r by 3. 2r by 3. So earlier time period was like t square is proportional to the length of semi major axis and cube of that. So the new time period divided by the old time period square will be equal to uh, 2r by 3 cube upon r cube. Okay, so t prime square is t square into 4 by 9. Check this. Am I right? So t prime is 2 by 3 times of t. No, this was not 4 by 9 into 2 by 3. So it would be root of this. Okay, let's read the options. So the period of revolution now becomes, there's some misprint here, 1 upon root 2 year. No, the period of revolution would become um, 2 by 3 this thing, these many years. Guys, I am having yeah, everything is okay. Yeah, okay, the period of revolution. Okay, and the next option, there is no change in the angular momentum. That is correct, because the force that was acting on the earth, it is still passing through sun. All right, so no change in, there has been zero torque on earth around sun, so the angular momentum will not change. So this part is wrong, this part is correct. Minimum distance is r by 3, we have calculated that. The maximum speed of earth, so to calculate the speed at this point, you can use that, let's say this be v prime, so you can use the fact that v prime into r prime would be same as v into r. So v prime would be root gm by r, this is v, into r by r prime. R by r prime is like r divided by r by 3, so 3 times the speed would be there. In fact, this was pretty simple. If the minimum distance is r by 3, the speed will, so the maximum speed will become 3 times. So this is correct. So option D is correct. So the correct answer to this question would be B, C, and D. So that was the question number 54th that we have done. Let's move to the question number 55 now. All right. So next question, optical fiber consists of a glass core of refractive index N1 surrounded by a cladding, a refractive index N2. N2 is less than N1, so the inner cladding is denser. A beam of light enters the fiber at P from air at an angle theta with the axis of the fiber as shown in the figure. Choose the correct option. So guys, let me make a simpler figure to understand. So from here, from the side, the ray is entering, and it is entering into a medium of refractive index N1. Okay, so this is the axis. Okay, so let's say this is the ray, this is again the axis, so it is coming at an angle theta, then it will bend towards the normal because it is getting into a denser medium, and then it will strike here. All right, and here we would want that this angle is greater than the critical angle. All right, so this angle, we want this angle to be greater than critical angle, only then it will undertake TIR. All right, so if this angle is I, we want I to be greater than critical angle. This angle would be 90 minus I, because this would be 90 degree. See, I multiply I multiply this entire equation with minus sign. So minus I should be less than minus critical angle. Now 90 minus I, I'm adding 90 degree to both sides. So 90 minus I should be less than 90 minus critical angle. Now I'm taking sine of both sides. So sine of 90 minus I, all right, should be less than sine of 90 minus critical angle. All right, so sine of 90 minus I, this angle is 90 minus I. All right, so this becomes sine r. Okay, sine r, where r was the angle of refraction for refraction at this point. So sine r should be less than cos of critical angle. Okay, and now I can multiply both sides with n1. So n1 into n1, Now this n1 sine r becomes equals to 1 sine of theta. All right, using Snell's law. So this should be less than n1 times cos of IC. So cos of IC is 1 minus sine square IC, and sine IC would be the rarer medium divided by the denser medium, refractive index. So it would be n2 by n1 square. So you take n1 inside this root thing. So sine theta should be less than root of n1 square minus n2 square. So theta should be less than root of, actually sine inverse we should use. It should be sine inverse of root of n1 square minus n2 square. So the maximum value of theta for which a ray can travel down the fiber, this is correct. This is incorrect because A is correct, so this can't be possibly correct. If theta equal to 30 degree, n1 equal to 1.5, then for reflection just at the critical angle. So if we are assuming that this angle is barely equal to the critical angle, then this equality should hold. So we are saying that sine theta will be equal to root of n1. So let's check. So the left hand side, according to the option C, left hand side becomes half. Okay, left hand side is sine 30, so that is half. Let's check the right hand side. Let's see whether they're equal or not. So n1 is 1.5 and n2 is root 2. So root of 1.5 square minus root 2 square. So this is root of 2.25 minus 2. So that's root of 0.25. That's 0.5. So LHS and RHS are coming out to be equal. So this option is also correct. Okay, and then option D says that a ray entering at theta equal to 0 travels a distance L from P to Q inside the ray fiber. Okay, okay. So we are discussing the travel of the ray along from P to Q. We are discussing this travel. Okay, we are discussing this travel, and this length has been given to us as r. Okay, let's try to understand this now. This angle is, let's say, angle of refraction. Okay, and this is the radius. This is the radius. Let the radius be let the radius be a. Okay, it is not given in the question. Let the radius be a. So this horizontal distance, okay, this distance would be how much? So I will write tan r. Tan r is equals to a by that distance. That distance, let it be x. So x, it is a cot r. Okay, am I right? Or rather, let's use this angle. This angle. D option is talking about at critical angle. Okay, so let me use this angle I. Okay, so in terms of that angle, it would become a tan IC. Okay, it will become a tan IC. And then 4 times. So L is 4 times of this. So L is 4 times of x. So this is 4a tan IC. Okay, this distance, this P to Q direct distance. Now to cover this distance, the time required, okay, the time required T1 would be L upon the speed in the medium, which is C by N1. So it would be N1 L upon C, and this can also be written as N1 by C into L. L was 4 times of A tan IC. Okay, A tan IC. Okay. Now we have to calculate T2. To calculate T2, I first need to calculate this length. So if this angle is IC, this is A sec IC, and 4 times of that, 1, 2, 3, and 4. So for the second ray, the distance would be 4 times of A sec IC, and then we'll divide it with the speed, which is again C by N1. Okay, so this time will of course be more. So T2 minus T1 is the delta T, and this would be written as 4a n1 by c, 4a n1 by c, 4a n1 by c, and then sec ic minus tan ic. So this will become 4a n1 by c, and then 1 minus sine ic by cos ic. Okay, and also we have to give the answer in terms of L. If you check the option, L has been used here, so I need to get rid of A. So to get rid of A, I am going to use the fact that 4A tan IC is equal to L. So 4A can be written as like N1, okay, 4A N1, 4A N1, this entire thing. I am picking the value of, okay, sorry. I'm picking the value of 4A N1 as, uh, no, just 4A. Uh, 4A can be written as L by tan IC. Okay, so this 4A has been replaced. N1 by C is at its place. 1 minus sine IC upon cos IC. Okay, now see this becomes n1 L by c, n1 L by c, tan ic and cos ic becomes sin ic, so it becomes uh, 1 upon sin ic minus 1, so this is n1 L by c, and then 1 upon sin ic. Sin ic was how much? Sin ic was n2 by n1, so this would be n1 by n2 minus 1. Okay, so this becomes n1 L by n2 C, and then n1 minus n2. Let's see the D option. N1 by n2 into L by C, n1 minus n2, n1. Yeah, so D option is also correct. Alright, so the right answer to this question would be A, B, and D. Alright, as we saw. So this is the right answer. Now we'll go to the next question. Okay, now this question says a series LCR circuit fed with AC resonant angular frequency. Okay, so the resonant angular frequency is given to us as 2 into 10 raised to the power 4 radian per second. When the same circuit is driven at a frequency which is higher than this frequency, it has an impedance of 1 kilo ohm, and the phase constant is this much. The values. So guys, we have to first write the equation. So 2 into 10 raised to power 4 should be equal to 1 upon root LC. That is first equation. The second thing is that when we are using a higher frequency than the resonant frequency, we can expect XL to become greater than XC. Alright, and now the impedance will be written as root of R square plus XL minus XC square. And the question says that the phase difference is 45 degree right now, and this value is 1 kilo ohm, so 1000 ohm. Now because this is given as 45 degree, so this must also be equal to R, so root 2 R should be equal to 1000. So from here we get R as 1000 by root 2, which will come out to be 1000 divided by root 2. This comes out to be 707.10 or maybe 11 ohms. So the value of R we have got, this has matched. Okay, and I think everything else is now very simple, because the new angular frequency is given to you, and you know that at the new angular frequency, okay, um, 2.5 into 10 raised to the power 4 is the new angular frequency. This multiplied by L minus 1 upon 2.5 into 10 raised to the power 4 into C. Alright, so this is equals to 707 or 1000 by root 2. Alright, so this is the second equation in L and C. This is the first equation in L and C. From first equation we can write 1 upon C. We need 1 upon C here. Alright, we can write 1 upon C as 2 into 10 raised to power 4 square of this multiplied by L. So let me use it here. So 2.5 into 10 raised to power 4 into L minus 1 upon 2.5 into 10 raised to power 4 into 1 upon C. 1 upon C is 2 into 10 raised to power 4 square of that into L, and this will be equal to 707. So this will become like, see, this 10 raised to power 4, will lose it, so it will become 2.5 into 10 raised to power 4 into L minus 4 divided by 2.5, that is like 8 by 5. Okay, 4 divided by 2.5, 8 by 5, 8 by 5 is 1.6, so 1.6 into 10 raised to power 4 L is equals to 707. So L will be 707 divided by 2.5 minus, so this is 0.6 into 10 raised to power 4. So let's calculate this. So this divided by 9,000, basically the value of R divided by 9,000. So this gives us 78.5 millihenry. So let's check the option. 0.5, yeah, 0.6, we can round it off to 0.6. Okay, so this is also correct. Now C you can easily calculate by putting the numbers here. I'm not doing that calculation now, but if you do that calculation, you will find that option C, I think you'll find option C as correct. Okay, you can finish the calculation and you can know. So this is definitely incorrect. So option A, B and C would be the right for this question. So next question, a long straight wire having a radius greater than 4 millimeter carries a current that is uniformly distributed over its cross section. The magnitude of the magnetic field due to the current is 0.28 meter. Okay, guys, so in this question we have been told that the radius is greater than 4 millimeter, but exactly how much is the radius, that is not given to us. All right, and we've been told that the magnetic field at 4 millimeter distance, so that is surely inside the wire. All right, because the radius is more than 4 millimeter, and we are now talking about magnetic field at a point which is 4 millimeter from the axis. So this is surely inside the wire, and then we have a different value at 10 millimeter, okay, from the axis of the wire. So let's first pay attention to a few things. Let's say this is the wire. Okay, let's say this is the wire. We don't know the radius, how much it is, but 4 millimeter is definitely inside the wire. So magnetic field here, let's say it is B1. So inside the wire, magnetic field is written as mu naught JR by 2. Here R would be equal to 4 millimeter, and this value is 0.28 Tesla, I think, 0.28 milli Tesla. Okay, now suppose if radius is more than 10, if radius is more than 10, we can see here that the magnetic field increases linearly with the distance from the axis inside the sphere. So if this capital R is more than 10, suppose, then at 10 millimeter we can expect a higher value of magnetic field. All right, but that doesn't seem to be the case. It is lower than what it is. So we can be sure that the radius is actually less than 10 millimeter, and this other point that we are talking about, the 10 millimeter point, it is surely outside. It is surely outside. It is not a point inside, because otherwise the value of B here would have been larger than 0.28. And because it is outside, therefore we can write the magnetic field at this point in terms of the total current. So we will write it as mu naught I by 2 pi r. R here is 10 millimeter. Okay, this value is given as 0.20 millitesla to us. So these things we have figured out. Okay, and now magnitude of the magnetic field at a distance of 2 millimeter from the axis. So guys, see, this 2 millimeter is half of 4 millimeter. So if 4 millimeter was inside the wire, 2 millimeter is bound to be inside the wire, and therefore we can rely on this fact that B is proportional to R. If we are talking about a point that is at a halfway distance as compared to this point 1, okay, then the magnetic field also will become half of the what we have at this point. So it would be 0.14. Okay, so 0.14 is correct. So option A is correct. Okay, then magnitude of magnetic field at a distance 5 millimeter is greater than that at 6 millimeter. Now guys, to decide option B, we must first find out the radius of the wire. We must try to find out the value of capital R. So we need to do some calculations now. Okay, so my plan is to actually take the ratio of B1 and B2. So if I take this ratio, it becomes 28 by 20. Okay, so that becomes 7 by 4. So this is B1 by B2 ratio. When I take this ratio, what gets cancelled? This mu naught gets cancelled. Okay, and I get J divided by I. Let me call this as R1, let me call this as R2. Instead of 10, let me write it as R2. So J by I JR1, this 2 will be here. In fact, the 2 will get cancelled. This 2 gets cancelled with 2. So let me get rid of this 2. Okay, so I have written JR1, 2 has got cancelled. From here, we will be left with I. I have written I. Pi is there. So pi will go in the numerator, and also R2 will go in the numerator. Okay, so this is what I get. Now J can be written as I by pi r square. Okay, I by pi r square, this is J, and then pi r1 r2, this pi r1 r2 by I. So I gets cancelled, pi gets cancelled. So from here we get the value of capital R. We are getting capital R square is equals to r1 r2 product into r1 r2 product into 4 by 7 into 4 by 7. So R1 was 4 millimeter. I think it was zero point 0.4 or 4. 4 millimeter and 10 millimeter. So R1 R2 product is actually 40 millimeter square. All right, into 4 by 7. So R would be 160 by 7 millimeter, root of this. Okay, so root of 160. So 160 divided by 7, and then taking root of that, we end up with a value which is 4.78. Okay, millimeter. So this is the value of capital R that we are getting. All right. Actually, I just noticed that I made a mistake here. It would be 7 by 5. This would be 7 by 5, guys. And so it would be 5 here. Let me change the color of the pen. It would be 5 here. It would be 5 here. So this would become 200. 200 by 7. Okay, 200 by 7. So the radius that we will get, it would be 200 divided by 7 and then root of that. So it would be 5.34 millimeter. So this is what we are going to get as the radius. So this option B talks about a point. This point is inside and this point is outside. So magnitude of magnetic field at B is, so B at 5, B at R equal to 5. How will you find that? It is an internal point. So we can do B1. B1 was this value. B1 was this value. So B1 divided by R1 into 5 millimeter. That should do the job for us. So B1 was 0.28 into 5 by 4. So this becomes equals to what? 0.07. So this becomes 0.035 millitesla. Okay, now B at 6. So B at 6, 6, this is an external point. So for external point, the formula is mu naught I by 2 pi r, or in other words, B like this point, you can write, you can multiply this 0.2 with 10 and then you can divide. So I will do 0.20 millitesla, that is this multiplied by 10 and then divided by 6. Okay, so into 10 divided by 6. So this will become how much? This is 0.2 into 10 divided by 6, that is 0.33 millitesla. So we can see that B at 5 is more than B at 6. Okay, so this is correct. B option is also correct. Now current flowing in the wire is 20 ampere. Okay, now to calculate the value of current, I'll have to do the calculations here. Okay, so let's do that. Mu naught by 2 pi, this mu naught by 2 pi, this is 2 into 10 raised to power minus 7. So mu naught by 2 pi into I. Okay, divided by, into I divided by 10 millimeters. So 10 into 10 raised to power minus 3. This gives us 0.2 millitesla. So 0.2 into 10 raised to power minus 3. So from here we are going to calculate the value of current and how much are we going to get. So this will become 10 raised to power minus 3. This will be minus 4. Minus 4 goes with this. Let me remove this also. So everything is cancelled now. And this 2 gets cancelled with this. So we are getting I as 10 ampere. We are getting I as 10 ampere, but this option says it's 20, so this is wrong. Okay, so this is wrong. And then D option says current density is 1.1. So we have found the value of I. In fact, we can directly find the value of current density using this formula also. But if you have already found the value of I think we will go with this, like 10 divided by pi r square. So R we found out to be 5.34 millimeter, or 200 by 7 millimeter. So this would be 200 by 7 and then 10 raised to power minus 6. Okay, so if we finish the calculation, it is how much? It is like 7 by 20 pi, or yeah, 7 divided by 20 pi. Okay, so this is 0.11 into 10 raised to power 6. So it is 1.1 into 10 raised to power 5. So this is correct. So the correct answer to this would be A, B, and D option. All right, good question again. Very good question, guys. Now we have a question on capacitor circuits, and it's actually a symmetry circuit. It's actually a symmetric circuit. The circuit is given like this. This value is C1 is 4 microfarad. So this is 4 microfarad. Then we have another capacitor here which is 2 microfarad. Then we have a capacitor here which is 2 microfarad. Then we have another capacitor here which is 4 microfarad. All right, and the middle capacitor is I think 3 microfarad. Okay, this is 3 microfarad, and this is connected with a battery of 12 volt EMF. Okay, this is 12 volt EMF. So first of all, if you notice that this circuit is symmetric about a point, and that point is the midpoint of the three. So once you have point symmetry, then like points that are images of each other, the sum of their potentials become equal to the sum of potentials of the point where battery is connected. So if I choose 0 potential here, then the potential here would be 0. This would be 0. This would be 12. Okay, this would be 12. And if I consider the potential here at V1, then the image will have a potential such that the sum of these two should become 12. That means the potential here should be 12 minus V1. Okay, now to find out the value of V1, what we are going to do, we are going to write charge. We are going to write charge on this plate, and this plate, and equate the total value to 0, because there is an island that is not physically connected to anything. So the net charge here ought to be 0. So V1 minus 12, that is the potential difference across these two plates, into the capacitance, that is 4, plus V1 minus 12 minus V1, so that will become 2V1 minus 12. We will multiply it with 3. Okay, and then V1 minus 0 into 2, that is 2V1 is equals to 0. So from here we get 4V1, then 6, and then 2. So 4, 6, and 2, 12V1. 12V1 is equals to 48 plus 36. 48 plus 36. That is 12 into 7, 84. All right. Or you can simply write 12 into 7, because that would be easier, like 12 and then 7. So V1 we are getting as 7 volt. So we now know that the potential here is 7 volt, which means that the potential here is 5 volt. Okay, now that you know the potentials here, you can calculate the charge on this capacitor, and you can calculate the charge on this capacitor. So Q1 would be equal to potential difference, that is 12 minus 7, 5 into 4. So that is 20 microcoulomb. Q2 will be equal to again 12 minus 5, 7 into 2, 14 microcoulomb. So the overall charge that came out of the battery, that came from the battery, is Q1 plus Q2. So the charge that came out of the battery is 34 microcoulomb, and this can be written as the EMF multiplied by C equivalent. So the value of C equivalent would be 34 microfarad divided by 12. So this becomes equals to how much? This is 34 divided by 12, that is 2.83 microfarad. So 2.83 microfarad is the value of equivalent capacitance. 8 by 3. 8 by 3 is how much? 8 divided by 3. So this is not matching. Okay, stored electrical energy. So how do we calculate the stored electrical energy? That would be half into C equivalent into V square. So that would become half into C equivalent was 34 by 12 microfarad. So 34 by 12 micro into 12 into 12. So one of the 12 gets cancelled. So this becomes 17. So 17 into 12. Okay, so 17 into 12, that is 204. So 204 microjoules. So the stored electrical energy, I think there is a typing error. I don't think that. Let me check the actual paper. So in actual paper this was joule, this was microjoule, so no error there. This option is correct. Potential difference between X and Y is 2 volts. So I think that is also correct. The potential here is 7, the potential here is 5, so the difference is 2 volt. So this is correct. The potential difference across C2 is 8 volt. So C2 is this one actually. Alright, C2 is this one. So the potential difference is not 8 volt, it is actually 7 volt. So this is incorrect. So the correct answer here would be option B and option C. Alright, so B and C, these are the correct options. Okay, now we go to question number 59. It says 1 mole of an ideal monatomic gas initially at temperature T is compressed to 1/8 of its volume in a piston such that the heat dissipated into the surrounding is equal to the change in the internal energy of the batch. All right. So heat dissipated in the surrounding, that means heat given to the surrounding is equal to the change in internal energy of the gas. Okay, now this statement we need to focus upon. Actually, there are two scenarios that are in my mind. Let's see. So let's say this is one of the situations, and the other possibilities again we have this. Okay, so in both we are compressing the gas by pushing the cylinder down. Okay, so the gas is compressed to 1 by 8 of its initial volume. All right, so in both the cases work done by gas is negative. All right, work done by gas is negative in both. Okay, work done by gas is going to be negative in both, and in both we are assuming that heat supplied to the gas is negative. That means gas has rejected the heat. Now what I'm not sure is that whether the internal energy increased or not. All right, the question says that the heat rejected is same as the change in internal energy. It doesn't say increase or decrease, and of course change also means one thing, that final minus initial, but I'll just keep both the options open and think about them. So let's say if I think that, okay, let's say delta U was also negative, and let's consider here that delta U was positive. Let's see which case will apply. All right, so according to these signs, what I'm saying is that mod negative of, so I'm putting this value is the first law of thermodynamics, so minus mod of Q. All right, I'm using explicit mod signs so that there's no confusion. So this equal to, we write delta U. All right, so minus mod of delta U plus W, which is again minus mod of W. So all things are negative here. So according to this assumption, we are getting mod Q is equals to mod delta U plus W, and according to the statement given in the question, Q and delta U are equal. So these two will get cancelled and mod W will become equal to 0, which cannot happen because compression is taking place. So that means we can rule out this possibility. So certainly this is the case that the question intends. So Q is negative and delta U is positive. So Q can be written as, or dQ can be written as, Q is negative, right? dQ is negative, so we can write this as NC dt. And remember, this is a negative number. All right, this is a negative number. Basically we want to write mod dq is equals to mod du, but we have to keep in mind that dq is negative and du is positive. So this is what we will write: mod dq is equals to du minus nc dt is equals to n cv dt. So c becomes equals to minus cv. So the process that we are doing in that, c is equals to minus cv, or we can say that c is equals to minus 3r by 2, because it's a monatomic gas. It is given that it's a ideal monatomic gas. All right, so the molar heat capacity of the gas is, this is wrong, there should be a minus sign here. Final temperature of the gas. Now let's try to understand. If C is equals to this, and it's a polytropic process because C is constant, we can write it as Cv plus R upon 1 minus alpha. So R upon 1 minus alpha, this becomes equals to what? This becomes equals to minus 3R, because the Cv will go on this side. So R gets cancelled, so we get 1 minus alpha is equals to minus 1 upon 3, or alpha is equals to 1 plus 1 by 3, so 4 by 3. So this means that PV raised to power 4 by 3 is a constant value. All right, it's a constant value. So the final pressure would be what? The final pressure would be initial pressure into initial volume raised to power 4 by 3 divided by V final. V final is V by 8. V by 8 raised to power 4 by 3. So this will become P into 8 raised to power 4 by 3. So that is 16. All right. So the final pressure is 16 times. Now final pressure is 16 times. Final volume is 1 by 8 times of the initial volume. So the product has become double. The product of pressure and volume has become double. So the temperature will also become double. So the final temperature would be twice of the initial temperature, and which means that delta T will also be equal to T. All right, now let's read the options. So final temperature of the gas is 2T. This is correct. Work done by the gas is 3RT. So work done, how do we write work done? Okay, work done by the gas. Okay, work done by the gas, maybe we can write it from here. That first law of thermodynamics tells us that work would be equal to Q minus delta U. Okay, and Q is negative, and it is equal in magnitude to delta U. So this is minus 2 delta U. This is work done by the gas. So minus 2. And what is the change in internal energy? It is N is 1, CV, all right, CV into delta T. So minus 3 RT. This is work done by the gas and it is coming out to be negative. That means work done on the gas is 3 RT. So this is correct. Okay. Equation of the state is, so we have already figured it out, that equation would be PV raised to power 4 by 3 equal to constant. So we already figured this out. So yeah, this is correct. And therefore the correct answer to this question would be option B, C and D. All right. And that brings us to the last question of this paper. This actually question is based on a concept that I will explain first. So let's say you have a round object and you are applying a force at a height h above the center of the object. So if you apply at force at a certain critical height, where this critical height is given as I by mr, this I is about the center. Okay, if you apply force here, then the object automatically, like object acquires V and omega such that V equal to omega r gets satisfied by itself. Now, for example, even if there is no ground here, let's say this object was hanging in space, in a gravity-free space, you applied a force at exactly this height. All right, then also it will move in a manner such that V equal to omega r will be satisfied, which means that had there been a surface here and had it been a rough surface, even then no friction would have developed, because this point is automatically having zero velocity. So when this point is not showing any tendency to move on the surface, why will the friction develop? Remember, friction develops when the bottommost point tries to move here and there, then the friction develops and prevents the movement. So if for example, if we exert force at a height which is greater than critical height, then this object will tend to have a larger omega as compared to V by R. Like in this case, the omega will become more than V by R. So this point will tend to have backward velocity. So friction will act in the forward direction and it will increase this value. It will increase V, it will decrease omega, so that the two can become equal. So that is the role of the friction. Okay, so let's now, with this background, let's now attempt the question. So it says that if we have exerted a impulse P, that's the total translation energy. So guys, even if the surface is rough, the friction here won't be impulsive. So right after applying the impulse P, all right, the center of mass will have a velocity such that it is like m by p, p by m, this velocity. So the translational kinetic energy can be written as p square by 2m. That is correct. All right, that is correct. P square by 2m. So this is correct. Okay, energy of pure rotational motion. So again, right after applying the impulse, there would be some angular velocity. Let's say omega naught. How do we get this omega naught, or what will be the angular momentum? That would be p into alpha h. All right, that would be the angular momentum. And how can we write the rotational kinetic energy? It's L square by 2I. Very similar to the translational part, that KT is P square by 2M. So P gets replaced by L, M gets replaced by I. So it will become P square alpha square H square upon 2I. I is 2 by 5 MR square. Okay, actually I think this alpha H is not correct. H is equals to alpha. So slight mistake here. I used alpha also, H also. So it should be like this. Like you have to write P into H, which will become alpha into R. So it would be alpha square R square. So R square gets cancelled. We get 5 P square alpha square by 4m. So 5p square alpha square by 4m. So this is correct. For alpha equal to h by 2, ball rolls without sliding. So let's check the critical height. So 2 by 5 mr square divided by mr. So yes, the critical height is 2 by 5 r, and so this is also correct. For alpha equal to 0, pure rotational motion. So if alpha is 0, then we are only applying the impulse at the center. So in that case, no rotational motion will take place. Like it will not take place initially. Like right after implying the impulse, the ball will begin to translate. If there is friction, which is not given, nothing is mentioned regarding friction. If the surface is frictionless, the sphere will continue to slide with the same momentum without initiating any angular motion. If the surface is rough, then of course the angular motion, the rotational motion will set in. So if alpha is 0, pure rotational will be observed. No, that is not correct. Like since at the outset only, at the beginning only, translational motion will be there, we can rule out this option. So the correct answer to this question would be option A, B, and C. Now that brings us to the close of this discussion. I hope you enjoyed all the solution, guys, and I hope the controversial questions, whatever explanations I gave you, you were satisfied with those. It was fun doing this solutions for you guys. I hope they benefit you. If you like the solutions, please hit the like button and subscribe our channel if you haven't done that already. That's all from my side. And one important thing, guys, if you would have probably noticed the Eklavya on all the slides. All right, if you don't know about what Eklavya is, inquire about Vedantu's Eklavya program. You would want to be a part of it at some point in time. On that note, I'll bid farewell to you guys. Take care, everyone. Bye-bye.